Hi, I'm Adam Crespi, and welcome to 3ds Max Revit Integration. In this course, we'll look at taking a model from Autodesk Revit into Autodesk 3ds Max. We'll start out in Revit, assessing our model, looking at breaking up large surfaces, assessing large areas, and seeing what we need to do for a smooth transition. We'll get materials on objects and get things ready to transfer over, and then we'll explore different ways of exporting out of Revit. In 3ds Max, we'll look at different import options and figure out what's the best one for our workflow. We'll look at how objects come in to see if they're instanced or copied, and how do we separate things by object or by material. We'll also generate some new materials here in 3ds Max, making sure that we get really good-looking materials applied to our objects. And as part of that, we'll explore modifying UVW mapping, seeing really how to get things textured properly so they look great. We'll augment some terrain and also look at adjusting lighting, wiring together lights on a dimmer. That way we can adjust them easily in an animation. Finally, we'll check out a little bit of rendering, using our rendering as a way to test model fidelity and see if there's anything we need to adjust when we finally get to our production rendering. Good design visualization is really foundational in communicating the design intent, and so getting a good workflow established from Revit to 3ds Max is crucial. So let's get started. For this course, a basic working knowledge of Autodesk Revit is helpful. At minimum, you should be able to navigate around in the view, switching between floor plans, ceiling plans, and 3D views. Additionally, you should be able to place objects and components by using families, choosing from architectural components such as windows, walls, and doors, and also choosing components and loading in families here. Some modeling skill in Revit is helpful but not entirely necessary. A working knowledge of 3ds Max is helpful but not necessary. We'll start with bringing in a model and look at some fundamental concepts like moving and rotating objects and positioning cameras. Along the way, we'll look at applying textures to our models, so some knowledge of creating textures in Adobe Photoshop or Algorithmic Substance Designer or similar programs again is helpful but not necessary. There are plenty of good courses on LinkedIn Learning on both, and so I'd highly recommend, if you'd like to augment your knowledge of what we're doing here, you take a look at those. If you have access to the exercise files for this course, you can download these files from the Exercise Files tab on the main page for this course. Here's how the exercise files are structured. In the Exercise Files folder, you'll find a folder for each chapter, along with 4 other folders of supplementary materials. The Exercise Files folder for Chapter 1 contains all the Revit files, one for each exercise. There's a start and an end, so at any point you can load up the starting Revit file for that particular movie. The exercise files for Chapters 2, 3, and 4 are 3ds Max projects. To set the project in 3ds Max, choose File and Set Project folder. Here I'm setting my project to Chapter 2, and you can see the other subdirectories 3ds Max creates as part of the project structure. Once your project is set, then open up the scene. In addition to the chapter exercise files folders, in the Custom Families directory, there are custom Revit families I've created for this project. There's cruciform columns, a new double storefront door, and the Modular Arts Apollo wall I've created from their Rockblocks collection. We'll be loading in those custom families in our Revit models. Additionally, there's a Knoll folder, and there's a selection of Knoll Studio furniture available. We'll place in some of these, Barcelona chair and a few other pieces, and you can place in other parts if you'd like to see how things come across from Revit to 3ds Max. There's a Philips light fixture if you'd like to experiment with it. This is the Day Zone, and there's 2 different lights in here, Day Zone Round and Day Zone Square. And again, these are Revit families of Philips light fixtures for placing in your model. Lastly, there's some reference imagery on the Santa Fe Savings and Loan, one of my favorite modernist buildings. This will give us good images on how to treat this building, how the sun looks or the lights look on various surfaces, and to really get a good idea of the original intent of this building. If you don't have access to the exercise files, you can certainly follow along using your own files in Revit and import those into 3ds Max. Additionally, you can bring in any of your own materials or textures that you'd like, or substances, to further augment your Revit model. Bringing a model from Revit to 3ds Max is fairly easy. From 3ds Max, we can either produce a rendering or go out to a real-time application for virtual reality or a tour through the building. When you're bringing a model over from Revit to 3ds Max, though, it's important to keep in mind some considerations that will affect the rendering later on, whatever form it takes. The first is to analyze large meshes and see where things can possibly have issues arise later when they're dealing in true light. I've got a model here I've put together, or at least part of one. It's still kind of in design in Revit, but we want to take it over to 3ds Max for more iterative design and better lighting, or perhaps go out and view it in virtual reality. What I'm going to do is to analyze this model to look for possible problem areas, and I'll start by looking at any large meshes. This building is directly inspired by the Santa Fe Savings and Loan, and I'll take a quick look at some reference on it to see how the real one is going to light. The Santa Fe Savings and Loan in Palm Springs by E. Stuart Williams is one of my favorite buildings. Built in the 1950s, originally as a savings and loan, and now part of the Palm Springs Museum of Art. It's a classic modern structure with round columns and cruciform fins welded on, holding up a flat white roof. Inside, we've got a curtain wall and perforated metal panels, shielding the building from the harsh desert sun. Around it is a low wall, with planting between the wall and sidewalk and the building. It's a really fantastic example of classic 50s modernism. What we can see in this is that this roof slab, and actually soffit or ceiling, needs to read as a contiguous piece. It's very flat. We do have some score lines along here, control joints. And likewise, we've got this floor slab that appears to float over the planting. Both of these are large objects, and that floor slab is contiguous inside. When we look at an inside view, despite being slightly pixelated, we can see that there's a clear view from inside to outside. Inside, we've got a poured terrazzo, as evident by the control joints and speckled appearance, and the view flows right outside to that concrete slab. Likewise, we see the same thing on the ceiling. That inside smooth ceiling flows right outside, really blurring the lines between in and out. These are the kind of things that are really terrific looking in architecture, but can be very problematic in a rendering if we don't account for them. Back here in Revit then, I'll take a look at some large meshes and identify possible problem areas. The first is the floor. I'll select it and isolate it to show what I've done. I've cut this floor slab out, a structural floor, cleanly around the curtain wall, or actually halfway under. And this way, I can cleanly isolate the outside, which is more likely to be in direct lighting from the sun, from the inside, which is more likely to have either dappled interior lighting from screens, plants, or interior lights, or muted lights through, again, screens where the sun shines through. Separating inside and outside floors then, even though they are the same structural slab, is important. I've reset my isolation, and now I'll go inside and take a look at the ceiling. I've set up some views here. I'll double-click on the Entry 3D view, and we can see here that I've got a contiguous roof slab, and then inside is actually a separate ceiling. I'll go into the Lobby view, and here we can see our ceiling object. This piece goes cleanly around, all the way around the curtain walls, as shown by highlighting, and right across this partition in the middle. We can see I don't have a floor yet, and that's one place I can go and add in other meshes. This ceiling may be problematic though, as there's a lot of places in this ceiling, and like objects, where I've got multiple lighting conditions that are going to try to hit one mesh. Additionally, we'll be punching some holes in with recessed can lights, and that in itself gets problematic in a large mesh, because we get long, thin triangles when we export this over to 3ds Max, and those can lead to rendering artifacts. So I'll tag this one as needing some attention, especially before I start punching holes in it. We also want to consider the lighting conditions on the inside. A ceiling like this, and the soffits on the outside. Most likely though, if we're trying to show a realistic view, this ceiling is going to be hit by all bounce light. And so this large mesh gives us the distinct possibility of many blotchy rendering artifacts if we're not careful. So it's wise to break up this as well. We've started to break up the floor, and you can see I've got this one slab for my entry. Maybe that terrazzo will be here. And then I can put in other floor pieces around, where right now it's blank. When you're dealing with a model then, it's a good idea to really start to separate things out, even though there may be pieces that are contiguous, to really make a difference between your structure, i.e. the concrete floor slab, and the skin or floor that's going to go on it, the terrazzo, the carpet, whatever it's going to be. And to start to break things up for rendering a little bit will save you a lot of grief later on. Almost everything in Revit is a family of some kind. A family is an external file, really. It's a particular product, maybe a door or a window or even a custom family, such as my Modular Arts rock block inspired Apollo wall. This is one of my favorites. I really like the way it provides this very tactile, ever-changing screen that we can see through but is an obvious barrier between spaces. Also, it fits nicely in the motif of this classic 1950s modern building. I've also got some custom families on the outside, my round cruciform columns, and I'll take a look at them. Round objects are often problematic in a renderer, and we'll delve in a little bit as to why. I'll double-click on my 3D views on the entry, and we can see here my entry stairs with my round cruciform columns. These are 4-inch diameter steel pipes with half-inch fins welded on, starting about 8 inches up from the bottom and ending about 8 from the top. We'll take a look at some reference on these on the original to see where there are possible problem areas. Here's our Santa Fe Savings and Loan, and we've got a couple of images of it. Again, this is one of my favorite modernist buildings and really poses some neat challenges in a rendering. I'll take a look at this image as it's a nice high-res image. What we can see here, and this is the building before it was reconstructed, is that we've got these round columns with steel fins welded on. They're 4 inches in diameter or so, fairly slender, and the fins are maybe half an inch or 3/8 of an inch thick steel. They start at about 10 inches up from the floor slab and end at about 6 from the ceiling. This is particularly problematic in a rendering. What we've got here is a different colored round form intersecting a flat ceiling. We're more likely to see it in a view like this than that super close up, where we're outside and taking in the whole idea of the building. The problems we see with a form like this, then, are twofold. One, it's intersecting different materials. We've got concrete against steel, steel against plaster, and they're different colors. So we've got clear relief of what should be a round against a flat. The other problem with these is that we've got a round form intersected by a flat form, these boxy pieces of steel intersecting that round column. When we take a look, we can just see that joint, and we need to see cleanly that it is flat to round to flat. If you'd like, you can go in and texture in the weld lines, although I'm going to leave those alone for this rendering. We can get fairly close, and as long as it's nice and dark in the corners, we'll be in good shape. What we'll see a lot of times is when we get a round form and a flat form pretty close, we actually get a light bleed in a rendering, and this is terrible in a real-time application where we've baked and simulated the lighting down to a pretty good degree. We tend to get a little bit of light showing right here where it should be all in darkness and all in ambient occlusion if we're running it. Therefore, I'm going to take a look at this family and make sure that this column is nice and tight and closed up. Back here in Revit then, I'll select one of my columns and edit the family. What I'll do is to edit this family and save it as a new version and load these in. And that way I've got my original and then I've got my modified version. I'll click Edit Family here in the Modify Columns tab. I've opened up that cruciform column family, and it looks pretty good initially. I've got a round pipe with the steel fins joined. I'll go into my lower reference level floor plan and take a look, zooming in close, and I can see a problem already in just the way that this was drawn. We're seeing that these lines are so thick I can't really tell if those steel plates are actually joining. So what I'll do is to select one of them and look at the object styles under Manage. And in here we can see that the cut line weight is 4. It's absolutely huge. I'll drop this down to 1. And now I can really see what's going on. What we're seeing here is that these are pretty close. It's decent, but not great. I'm going to redraw the extrusion for the pipe here, using a polygon actually instead of a circle, to give me a flat spot to actually join on these boxes. Later in 3ds Max, I can smooth these columns if need be, and still have these exactly meet. Alternately, you could model this with extra lines and weld the vertices, but I have chose to model this all in Revit, so I'm going to fix this column here in the family. What I'll do is click Edit Extrusion. I'm going to draw another polygon inside here and then delete that circle. For this, I'll use an inscribed polygon. I've got the side set to 16. And in here, I'll click and drag on the center and pull out to 2 inches. Now I've got my polygon and I can delete my circle. The X, pick that circle object and delete. It looks pretty good, but there's one more fix I need to do. We can see that I've got each of these pieces of steel actually hitting a point, and so I'm going to get a little gap here, which again will give me a lighting goof, or a shadow artifact, or light bleed, or something similar. What I'll do is to pick this object and rotate it, starting at 0 and rotating around until those go flat. Here's 11.25 degrees. And now I've got a flat side, pretty close in size to that steel, facing out to the steel. This way, two things I've got that'll really help. One, I've got a flat side where I can join that steel on, and two, there aren't cardinal points, vertices, aligned with that steel. So if I happen to see this in contact with another material, I'll see a flat side trending towards round instead of a point right here under a flat steel. And it's just enough that with any anti-aliasing, it'll blend smoothly, and I won't be able to tell that it's actually a faceted object. Now I'll move that steel in. I'll click the checkbox to finish the edit mode, and then zoom in on the steel. I'll pick each of my steel pieces, and what I'll do is make sure that they are moved and snapped down. We can drag them nicely, or move them cleanly and snap them on. What I've also done here is to look at this measurement. This is 6 inches cleanly. We've got our 2-inch radius column and a 4-inch piece of steel. I've snapped these in, and this should be a much better column, where I've got those flat sides and that steel intersect cleanly. I'll save this family as something different, choosing Save As, Family. I'm saving this family as crewcolumn2.rfa. You'll see this in your exercise files folder, so go ahead and save over it once you've done your modifications. This way, all the other Revit files from this chapter on can reference this family correctly. Alternately, you could save it as a different name, Crew Column 3 or something else besides what's in your Custom Families directory, and import that into any project you'd like. Now I'll hit Load into Project and Close. I'm back here in my Revit project, and I'm going to replace all of my columns. I'll open up the columns in the project browser, and there's Crew Column. I'll pick my cruciform fin column and right-click on it, and choose Select All Instances in the entire project. Now what I'll do is to drop down under that Family and choose my Crew Column 2, cruciform fin column. They all updated, and there was a subtle change there. We actually have all the different lines showing. If you'd like, you can always go into this project or into that family again and start making lines invisible or changing the drawing style. For now, though, I'm going to leave it. What I've got is exactly, well, what I want for a rendering. 16-sided, faceted columns that have flat spots my steel can join onto, so I get a clean joint between the flat steel and the round column. And then there's enough sides, 16, that 4-inch column, as seen from a view like this, or even a close-up view down here on the slab, are still round enough that they'll look round. As a final test, I'll do a quick render here. We can switch the visual style just over to Ray Trace and see how it looks, or actually do a rendering. I'm here in interactive ray trace mode, and it's good enough. Where I'm looking in this is right here, this one column that's out here in the sun, clearly in view, on the slab, in the entry, in a very typical shot for this kind of building. And it definitely looks round, and I've got a nice clean joint and shadow line here, right where this steel joins. My other columns that are all in shadow are, well, all in shadow, so it's working nicely. We need to make sure we pay attention to these round objects, that where they intersect is taken care of in advance, because we're using them often in dozens or hundreds. That is, we may see a ton of these family objects, and so we need to make sure our round families stay round correctly, so that when we render, they show up nicely without artifacts. When you're working in Revit and planning on taking your model out to 3ds Max for a rendering or out for a real-time simulation, it's a good idea, as I've stated, to break up large meshes, and this is especially true when you're dealing in a mesh that may have holes punched in it, such as our ceilings here in our bank, which may get recessed can lights. The original has tall surface mount cans, but I'm going to recess some here over this screen wall. Later we can add other fixtures in that are surface mount. I'll go into my floor plan, scrolling up in my project browser, and clicking on Level 1. What we can see here is that I've got curtain walls around the perimeter, and a bathroom or similar shape in the center. What I've done is to plan this in loosely. Again, I'm using this for design and iteration. We can also see that I've got a partition wall here, kind of sectioning off maybe the main entry and lobby, and if there's a reception desk, from other things going on. Maybe we'll convert this to an office or something similar, and we want to have public and private division. What this tells me is that I really need to break up this ceiling in a couple of different pieces. I've definitely got kind of a large piece back here in back of this partition, and then another one here in the entry. We may have different lighting in each one. There's definitely going to be another large piece here, and then I've got to worry about this bump out. Maybe this used to be a separate side entrance or something similar. Also, I'll need another ceiling piece back here. Maybe this is where I'll have the employee lunch or something similar, and it's definitely going to have different lighting. The other reason to break up objects like the ceiling is to make sure that you've got the ability to show enough lights on each piece, especially if you're dealing in real-time lighting. If we're dealing in one big ceiling here with a hole punched in it, there's a good chance that we'll start to see lights wink out in a real-time simulation. What that means is that an object can only have a certain number of lights on it. And so the more objects we have, the more each one can support multiple lights and so look right in our lighting. I'll go into my ceiling plan then for level 1 and now start to box out my ceiling. I'm going to do this before I insert the can lights. So when I'm inserting can lights, I'm inserting them in one piece, not a whole bunch of ceiling. I'll zoom in over on that entry section, as I'm going to put some recessed cans and maybe a pendant in here. Under Architecture, I'll click on Ceiling. Instead of using the automatic ceiling, I'll click Sketch Ceiling. And now I'll start to line out the boundary. I'll use my line and make sure I've checked Chain. Now I'll start to line this in. For this particular ceiling, I'm going to go from the front of this boundary wall. I'll go over and cleanly meet my curtain wall. Back to the grid. Now that it's closed, I can create this ceiling as this one piece. If you noticed, I did go around the wall here. At some point, we need a joint in the ceiling, and we can either center it on the wall or go in front or back. I think what I'll do is actually move it to center on the wall. Picking Move and selecting this line. Then what I'll do is pull it over. I'll let it snap right to the center of that wall. And this way, if I need to put in a control joint or similar reveal, I can. When you're done, click the checkbox, and there's that ceiling. I'll check it out in my lobby view. It's good, but it's at the wrong height. What I'll do is put the height offset up to 11 foot 10. I'm going to let it drop 2 inches below that roof slab. Now I can start to delete the other parts of my ceiling and remake them. Again, would I sometimes put in one whole ceiling here for design in Revit just to see how it flows? Yes. And then I might come in and either edit the boundary or delete and remake prior to putting in can lights, just to make sure that everything joined cleanly and round shapes, such as punch cans, had the opportunity to go in a smaller piece of ceiling instead of the whole thing. This ceiling starts at 1110, but this wall here looks like it goes up to 11.8, so we need to make a decision as to which is the height. Being that this curtain wall system top mullion is 2.5 inches thick, I'm going to let the ceiling be the decider at 1110 or 2 inches. So I'll make sure that this curtain wall then has a top offset of -2. Now we can go and build in the rest of the ceiling. And again, I'll do this in Ceiling Plan Level 1. We've got to make some choices here as to how things start to align in the ceiling, and will we see further detailing on it. I'm going to do this next ceiling as a clean rectangle around this wall on the center here to this window mullion, and then let these other pieces be part of a different ceiling. Again, under Architecture, choosing Ceiling, I'll sketch it and work by line. Matching the other side, I'll go from the center of this wall up to the curtain wall. We have a little bit of a mismatch in where those lines go, and that may be something to sort out and design later. Alternately, we could move the walls so they actually do align. Now I've got my ceiling. I'll check it and check that height offset again. I've set it to 11 foot 10 inches, and I'll click Apply, and then go into my lobby camera and see my ceiling. It's working nicely. At some point later, we could come in and put in a reveal. Maybe it's an aluminum channel or something similar, but for now, it's working well. What this also gives me then is the possibility of constraining down punched openings for lighting. So when I start to add them in, they'll go in discrete pieces. If you'd like, you can finish out the rest of the ceiling or simply leave it and progress with the rest of the design. I've finished out my ceilings. We can see that there's the drawing lines here, showing some divisions between them, but they should render fairly smoothly. This is an opportunity again to put in something as a trim line. The original building has reveal channels, maybe an inch square, demarcating different parts of the ceiling and lining up with the columns and the rest of the building grid. So that's an option here, also to reduce the size of these ceiling pieces even further and add in those details. This is your call. I'm going to let my ceiling here be fairly contiguous in big parts for lighting, and say that at some point later I'll come and add in recessed cans and so on. But having this broken up in multiple pieces will make for a smoother rendering with fewer artifacts in general. One of the great things about Revit is that so many manufacturers offer their products as Revit families. We can easily load in furniture, fixtures, equipment, flooring, all kinds of things. From sprinkler heads to put on the ceiling down to classic office furniture to put in our entry or a lobby here. I'm going to load in a family and look at how things come in and how much, well, roundness they have and what do they need. This is particularly important because we want to make sure that things that are intended to be round and possibly soft actually look round and soft. I'll drop down under Component and choose Place a Component, and then I'll load in a family. Right now it looks like it's defaulting to a parking space, which is not what I want to land in the inside of my building. I'll click Load Family. In the Exercise Files folder, I'll browse into the Knoll folder. These are a small selection of the many families offered by Knoll. I've gotten here the classic Mies Barcelona chair and couch, some Lovegrove table desks, and also a Florence Knoll bench, a good selection of office furniture with a decidedly modern bent that'll really fit this building. I'm going to bring in the Barcelona chair and take a look at it, and put a couple of these here in my lobby. I'll select the Revit family, and we can see here in the preview it's definitely got some curves to worry about. There's the tufted leather seating and also the classic curved legs. The model was upgraded from 2014 to 2018, and now under Properties I'll drop down and choose that family. There's our Knoll Studio Mies van der Rohe Barcelona chair. I'll pick it, and I can place it in. If placing in a 3D view is a little awkward, you can always go into a top view. Here's 1, 2, and 3. I'll right-click and choose Cancel, and then go align these nicely in my floor plan. I'll zoom in, and what I'll do with these is just move them back so they're roughly even on the edge here, and get them pretty close. Rather than use the Align tool and get them exactly perfect, I want them to be ever so slightly off. They were placed there by people after all. We want them to be, well, pretty close to the edge and just about the same distance apart. This gives us a slightly, perceptibly less perfect feel and makes the rendering feel, well, more natural. If things are exactly, absolutely, perfectly aligned, such as chairs, it can look a little funny. Some things should be perfect, like the column placement. Some things like chairs need to have just the tiniest bit of wiggle. I'll take a look here in my lobby view again. Right now, I'm running in fine mode. We can see here, when I switch back over to a detail level of medium, these become quite boxy, and this lets us move around fairly nicely. We can see in contrast that this Apollo wall only has one level of detail. We'll have to make sure we look at this when we bring it into 3ds Max and see if it renders smoothly. These chairs, though, and I'll pick one and isolate it, and take a look, have a lot of detail on them. I've switched back over to Fine, and I'll orbit around. I'll go to my 3D view, and make sure I isolate that chair again. I'll work in realistic mode and check it out in Fine. What we'll see here is that I've got pretty good detail on it, those cushions are definitely modeled to have, well, a little bit of a roundness to them. We can also see that all of the piping between and the way those squares are tucked is modeled in. So it's a fairly high poly object. This will come across fairly nicely. What I'll do is eyeball things like this to see how is it going to look when we see curves from the side. When we view our chair like this, we can see that that curved leg reads as fairly smooth. And even in zooming in and dragging around, we can see that we don't see too many facets, so we're in pretty good shape. We'll keep an eye on this in 3ds Max to make sure that we don't get too many polygons when it comes in, but for now it looks pretty decent. This kind of thing is a centerpiece, so we need to make sure it looks right. We also want to make sure we look at it from glancing angles. We want to make sure that things like those famous cushions do actually have a little bit of silhouette to them, that they're not entirely flat. This looks like it's done well. I'll reset my isolation, jump back into my entry or my lobby view, and there's my chairs, and I'm ready to bring in other pieces. We'll take a quick look then at this Apollo wall in contrast. I've got it selected, and we can see in this wireframe view that there's, well, a ton of polygon lines here. I'll isolate it and see what's going on. In realistic mode, where I get decent shading, we can see in here that it's definitely got some faceting going. This was modeled externally and brought in as an SAT file. We can often model things in 3ds Max or Maya or something similar and bring them in. This is a possible candidate for one of two things, either some smoothing later in Max or remodeling here, using this as our low detail or coarse mesh, and then actually making a much nicer fine res model. And we'll take a look at why, looking at some reference. I've opened up the Modular Arts site and gone into their rock blocks. These are really fantastic. What they are anywhere between 4 and 6 inch thick pieces. They're very tactile, 24 by 32, and 24 inches wide by 32 inches tall, and modular. They repeat very nicely. They're really sculptural screen walls, as the quote says. And what I like in this is how they catch the light in the design. As opposed to more of a flat tile on a surface, these actually have really terrific relief. There's a new one in here, the mid-century, another one of my favorites. And again, it's terrific because it's got detail in these blocks and voids through. I've chosen to use the Apollo. And what we can see here when we look at images of it, and what we need to be careful of in our model, is that it's, well, nice and smooth. This needs to render, as we see here in the photo, that we've got a contiguous flat face, curved sides, curved top and bottom, and only a nice crease at those corners. So unlike the model we've got, this one is pretty smooth. Back here in Revit then, I can see that this is decent. It behaves fairly nicely in a rendering. I'll get out of the isolation and check it out. Here in my lobby, I'll switch over in rendering modes. I'll go from a visual style of shaded to either realistic or ray trace and see how it looks. It's decent, although in ray trace mode it's a little tough to tell. This may be a place to do a quick render here in Revit to get us a better look. What I'll often do is test out my round objects to make sure that they look, well, nice and round in a render before I export them across. And this way, if there's anything I need to fix in a family and then have those changes propagate through many objects, it's better to do in Revit than it is to try to touch it up later, even though things may come in as an instance. What I'm going to do is to move that camera closer. I'll go into my floor plan, going back to realistic, select my camera or show it, making sure I show the right camera, and I'll pull this camera forward. Keep in mind where you're viewing your objects from when you're determining roundness. We can see with this camera, and I'll select the camera here, that got a far clip of 100 feet, and the eye and target elevation are somewhere between 5 and 5'6" off the floor, and this is very typical. When we're dealing in room space VR or just a fly-through in a building, we typically want to see it initially, at least, from an approximate person height. So that's what I'll use as a judgment on my round objects. Here in my lobby then, I can see the chairs hold up nicely, and when I switch over to ray trace, this wall doesn't look too bad. A little smoothing in 3ds Max, and it should be fine. Once these polygon lines are smoothed over, we can see that it's close enough to that round flatness, or whatever we want to call it, that it'll hold up nicely as that screen wall. My chairs look good, and so my families with roundness are good for the moment. I'll leave them alone, as I think we're going to be okay with it. It's always a good idea to look over objects, making sure that they're not either excessively modeled or under-modeled, so that they render correctly and really get the nuance of the intended product across. Often in constructing a model, we want to add small details into a larger, room-spanning object. In this case, I'm going to put some recessed lighting into my ceiling over my lobby. The original building had surface mount cans, and these were quite tall, almost 16 or 18 inches, and very big. I'm going to put in some more typical recessed cans, as we'll see these often in a structure. Then later I'll add in some other surface mount fixtures. I'll go into my ceiling plan and make sure I've got my family for recessed can lights loaded. I've zoomed in on that lobby, and under Component, I'll choose Place a Component. I'll click Load Family, and I'm going to bring in from the default US Imperial families under Lighting, Architectural, Internal, and there's my downlight recessed can. You could also choose a downlight round LED or something similar if you'd like. I'll choose a very typical recessed can, and know that we can always change this if we need. I'll click Open, and drop down under the Properties and the Families, and choose that can. As I had used it before, it shows up in my most recently used types. You can also scroll through this search list, or find it by typing in the top search bar. I've got my can light here, and I'll put the elevation to match that ceiling at 11 foot 10 inches. Right now, all the data it has is really on the electrical side. What's it going to do, what's the wattage, and so forth. I'm going to space these at every 4 feet in front of this sculptural wall, so we get some good wall wash with the light later. Here it is at 4 feet off the wall and 2 foot 6 out. There's 1, 2, and 3. Now that these are in, I'll go check them out in that lobby view and see if there's anything I need to adjust. They look good. As they're supposed to, they've punched their holes automatically in the ceiling. We can see here when we select that ceiling mesh that it's got that recessed can in it. What we'll see with this is that from this recessed can light, we're going to get triangular faces from all the sides, all the vertices, out to the different corners of this room. And this really illustrates why we want to break up these large surfaces. What I've done by breaking this up and then planning in those can lights is allow this to connect very nicely in shorter runs to the corner and other places, rather than seeking out the nearest vertex, which may be way across the room, would get me huge, long triangular faces. We can add in other round objects in this if we need. We could put in more recessed cans, maybe in offices, or start to add in surface mount fixtures. It's important, though, again, to really start to break up the large objects so they light nicely. I'll add in a few more, and then see how they look in this space. I've put in a few more, and I'll take a quick look at them. This is a can light, although it doesn't necessarily have a light in it. It's up to you if you want to put a light in here or do it later in 3ds Max. I'm going to leave it alone for the moment and just take a quick look in a rendering. It's working nicely. Even in a ray trace rendering here, the interactive ray trace mode, we can see that I'm getting a nice smooth ceiling. That joint there is where those two ceiling objects join. It actually kind of works in this design. If you'd like, proof this through in a rendering, switching back over to Shaded and clicking on the Show Rendering dialog. I'll put my settings up to Best, render a region, set the sky at No Clouds, and choose Interior, Sun, and Artificial. I'll hit Render to see how this looks. My render is done. It's way too bright. I'll click on Adjust Exposure, and what we can see in here is the exposure value is too low. Here's an exposure value of 15, and it looks much better. Actually, I'll bring this down just a touch, maybe in the 13 range, and it's nice and bright. What we can see here is this punches through very well. We've got our round can lights, really almost circles on the ceiling, And there's no artifacts, that the light is coming smoothly across here. It's working nicely. Now bear in mind I haven't done anything to really touch up the lighting other than put stuff in and deal with the default sun. But in a typical situation where this is lit largely by bounced light, my ceiling, even with all these holes cut in it, is behaving well. If you'd like, you can add in more can lights. I'm going to stick with the 5 I've got here as kind of an accent over this wall, and then later we can add in pendant fixtures if we need. When your model is ready in Revit, it's time to export out to 3ds Max. And there's several different ways to do this. They all have their advantages and disadvantages, and I'll take a look at some of the common things available. We'll choose File, and under File we've got Export and Suite Workflow. A Suite Workflow, and this is fairly new here, allows you to export out to 3ds Max Design for interior-exterior renderings. The advantage on this is it's a one-click out there and ability to get a rendering quickly. The big deal is really saying where does the design flexibility come in and how do objects break up or not. We want things to come in properly, and we realize that they may need some editing in 3ds Max to behave correctly. Also, if we're going out to a real-time simulation, we may want things put together differently than if we want a rendering. I'll choose 3ds Max Design Exterior Rendering and see what happens. I'll look in Settings, and what we've got here is basically FBX, and that's actually what's going on under the hood. In here, we have the ability to say, what is our target linking, and are materials coming across or not? Also, are we taking lights, a daylight system, a camera, and so on? And are we auto-smoothing adjacent faces? And this is a good thing. A lot of our models are set up for auto-smoothing, such as that Apollo wall and those cruciform columns. In the Suite Workflow then, I'll send out for an exterior rendering and click Run. What this will do is open up 3ds Max and import in that design. I'll click Continue, and we'll open up 3ds Max. 3ds Max is opened up, and we can see our scene here complete with the camera. I'll maximize the viewport by clicking on the Maximize Viewport toggle in the lower right. We can see our daylight system, and there's the sunlight, and the exterior camera. I'll click C for camera to go into that view. The big deal is not really can we bring stuff in, but how does it come in? When this came in, what we can see here when we select things is that everything's separated, which is actually really good. Here's our cruciform column, our curtain wall elements, and so on. And these all list out here over in the Scene Explorer. There's quite literally dozens, if not hundreds, of corner mullions and wall blocks and so on, all named as they were in Revit. The big deal is to really look at the objects in the modifier panel. What we can see here is that this is an editable mesh, this cruciform column I have selected. The downside is that because it is linked geometry, it is not an instance, it is unique. We can reset the position if we need, bring it back to its original if we move it. The big deal, though, is to say where do we want the artistic flexibility and the ability to tune things. Right now, these are all unique objects, which means if we go out to a real-time application, they may be unique and hence not editable very easily. We also want to edit things a bit here, and so having these come in as unique is problematic. I'll go back to Revit and look at another option. Here in Revit, what I'm going to do is actually export this out as an FBX instead. A bit more manual of a process, but it gives me some advantages on the incoming workflow. I'll choose File and Export. And in the export out an FBX. I'm going to export out an FBX. I've put it into the Chapter 1 Exercise Files folder. And I'm going to make a new folder here. In here, I'll call this folder Exports and put this file into it. When we export out an FBX, there will be the FBX and some other files for the material definitions and other pieces. So I'd like to keep it contained within a subfolder. We can choose in here, with a boundary edge or without, and using LODs or not. I'm going to leave it alone, so it's simply coming in at the res we're seeing it as here in Revit. I have things set to fine detail, so we're seeing the detail in my Barcelona chairs very nicely, and that's what will come across. I'll click Save and export out the FBX. Now I'll go into 3ds Max and import that FBX and see how it came across. Here in 3ds Max, I'll make a new scene, just choosing File, New, and New All. I'm not going to save that test scene from the Suite Workflow. Now I'll import the FBX, choosing File and Import. We've got a couple options here, import or link FBX. A link then links to that file, basically functioning as a reference, whereas import actually imports the FBX with no connection into the scene. I'll choose link FBX, and there's that FBX file. I'll click Open, and the option in here then is to choose how are we managing those links. Right now the preset is the Autodesk Revit combined by Revit material, and this can be problematic. A lot of things in my scene didn't have a material in Revit necessarily, as I was planning to put them on here. So this means that a lot of things would get combined. We've also got things like combining by category or family type. We can bring things in as one object, which means the entire building would come across as one, or do not combine entities. We can also bring it in as a generic or FBX to 3ds Max workflow. I'll take a look at what the combined Revit material does. I'll make a daylight system, and this is where things get interesting. When we zoom in, what we can see here when we combine by material is that things that either didn't have a material assigned or had a like material get combined into one object. So here I've got selected a generic mesh, which is my cruciform columns, Apollo wall, and my chairs. Highly problematic for rendering, as we just went through a lot of effort to separate things. I've made one more new scene, and what I'll do is choose File, Import, Link FBX, pick my FBX, and instead choose Do Not Combine Entities. This is better. What we'll see here, and I'll press C for camera, is that I've got my columns and they are unique. The downside is, well, they are unique. The Make Unique button is not available, and so I'm somewhat back to where I started, where everything came in, which is great, everything is separate, which is great, but I lost my artistic flexibility in the ability to edit here in 3ds Max like objects like my columns. I'll show one more way to do this, and that's where I'll leave it. I've made a new scene, and I'm going to do something different, choosing File and Import. And now instead of linking, I'll import the FBX. Here's why. In the link, I've preserved everything as unique, figuring I'm going to adjust things back in Revit and update the link. However, I want to adjust things here in 3ds Max and see those changes propagate. At some point, you may decide that you don't want to round trip to Revit for the alterations you're making. You're using 3ds Max either for cleanup and real-time simulation transfer, or to do a render, and it's not going to go back to Revit as a model. I'll choose Import, pick my FBX and Open, and there's a standard FBX dialog. And in here, we've got options over Bring in Geometry with Smoothing Groups. Yes, I'd like to. Do we want our lights and our cameras and our sun and sky to come in? Yeah, I'll bring in the sun and sky. We can also create one here. Do we want cameras? Yes. I don't have any animation, and this all looks good. I'll click OK. My model will come in, and I get something very neat. One of my columns, when selected, shows the Make Unique button available. What this means is that if I make a change to one, they all will change. For example, taking the top vertices, pressing W to move and pulling them up, means that they all change. So when I get in here and do things like adjust smoothing groups and make sure things work right or unwrap, all of them will get it properly. I've made a conscious choice in this case to import the FBX and break with the layout in Revit and give myself some artistic flexibility here in 3ds Max. Again, this is an artistic choice. I'm making a choice to have a one-way transfer once and a manual update process, knowing I'll take the hit in time, but there's things I want to do here to optimize the rendering, versus a round-trip capability and possibly losing flexibility in what we do here in 3ds Max. Now that I've got this imported in, I'm ready to start modifying things and really putting some polish on this model. Importing a file into 3ds Max is fairly straightforward. Before importing, though, we should really look at our project setup, and I'm going to show bringing in that FBX one more time. It's important to bring it in correctly. It is fairly straightforward, but there are some minor places you can get stuck on if you're not careful. What I'll do first, though, is to set up my project. I'll choose File and Set Project Folder. A 3ds Max project is a relative project structure. It'll have subfolders in it, such as scenes, scene assets, our images that are parts of our textures, import and export, and so forth. I've browsed into my exercise files folder into the Chapter 2 section. Your Chapter 2 folder will come with a 3ds Max project set. And so if you're working in a different directory or without the exercise files, you can make a project. Alternately, you can simply set your project to this folder. I'm going to let the Chapter 2 folder be the root of my 3ds Max project and let the other pieces go in there. All the scenes for this chapter will go in the Scenes folder and so forth. I'll click OK. I'll open up my Explorer and see what happened to that directory. Here in the Chapter 2 Exercise Files folder, we can see that 3ds Max has now created subfolders. Your Chapter 2 Exercise Files folder will have these subfolders in, but you'll use the same process of setting that 3ds Max project file. We can see I've got an exports directory, my exports I put out from Autodesk Revit. And there's actually an export directory from 3ds Max. What I'm going to do is to make sure I move the exports from Revit into the import directory. Your exercise files folder will have it already in the import directory, and this just has our working FBX to bring in. The other folders are fairly empty. We've got scenes, where our scenes will go, scene assets, where our images that are part of our textures will go, and other folders for previews, proxies, export, autoback, and so on. Now that this is set, I'll bring in my FBX, choosing File and Import. And I'm going to import my FBX, choosing Import. And in the Chapter 2 Exercise Files folder in the 3ds Max project, I'll choose Import. In that Exports directory, what I had put out from Revit, there's that 0201 Modern Bank Start FBX. I'll select it and click Open. In here, what we can see in that System Axis direction is that Z is up, which is true in both 3ds Max and Revit. The File Axis direction is Z, and System is Z. We can see in here our system units is set to inches, as I was using the Imperial template in Revit, so it's coming across correctly. And this is important to note. That building is comparatively small. It's really not a very well detailed building, it's just got a few pieces. And there's already almost 400 parts. If you're dealing in a larger structure, you may see several thousand, so how you organize and how you bring things in is very important. Scrolling down again under Geometry, I want to bring in smoothing groups to make sure that things that should be round are round. I'll bring in my cameras. I don't have any animations set on at the moment, and I'm going to bring in the lights. The sun and sky are optional. You can create one here in 3ds Max, or you can import from Autodesk Revit. For this rendering, I'm going to uncheck Sun and Sky and simply use my interior lights. I'll bring in the lights as I had placed them in carefully as part of placing in those light fixtures. There's no audio with my file, and under Advanced Options then, I have control over Units and UI. The units are set correctly, from feet to inches, and under UI, are we showing warning and log data. I'll click OK and bring in this FBX. As we saw previously, my model comes in. Everything right now is selected, and when we deselect and pick one object, scrolling down and choosing one of our cruciform columns, we see most importantly, there is a Make Unique button available, so that changes made to one will propagate through all of them. Pressing C for camera takes me to that entry view I had set up, and then clicking on the 3D view entry allows me to choose that camera or another view. If there are multiple cameras that were brought in, showing in Revit, we could bring them across. At the moment, I only had that one view, so that's what came in, baked as part of that FBX. My lights came in, off at the moment, and shown as these black cones. Now that this is imported in, I can look at other things in here and make sure my textures came across as well. What I'll do is to click on Standard and choose under Materials, Realistic Materials with Maps. I want to make sure in this case that some of the images came across as part of the material, although I may end up adjusting those later. We've got a couple of different things we can bring in here. Shaded materials with maps, realistic materials with and without maps, and an override with either a fast shader or a UV checker. I'll go with realistic materials with maps, and Max will take a second update, and there's the materials as they were in Revit. My generic CMUs here, the stairs with some sort of concrete texture, and anything else that was defined in the family as having a material with those images. We can just see the doors in the background have a little bit of a wood color on them. If you'd like to check how the mapping came across, you can also choose under Materials, Override with UV Checker. And this is a neat one. Aside from a fairly crazy looking view, what this also tells us, and I'll go into perspective by pressing P, is that the UVs in Revit may need some work. So did this come in correctly? Yes. Does this need a little help? Yes, we can see definitely some stretching and odd application in places, and also places where we've really got some scale differences in the UVs we need to play with. When we zoom in on our wall then, we can see in here that we've got our grid squares numbered and they're facing in the right direction, but the way this tiles across this wall may need some work. I'll go back in my materials to realistic materials with maps and turn off the override. Now that the model is in, we can start adjusting geometry, smoothing, and mapping to really get this tuned up for either a real-time application or our rendering. One last thing, make sure to save your scene. Choose File and Save. I browse to the Chapter 2 Exercise Files folder, and in here I'll go into Scenes and save this scene. I'll call this one 0201 Modern Bank N.max. You'll see this in your Exercise Files folder. I'm going to save it in here, so you can save over mine or give yours a different name if you'd like. Now that we've brought our model in, it's time to look at the smoothing groups on different objects, or rather to put some on. My model looks okay, but when I zoom in on some of the elements like the cruciform columns, we can see they need a little work. I've pressed P to go to the perspective view. I'll select the column and hit Z for zoom extent selected. I'll use Alt and the mouse wheel to orbit around and zoom in down at the base. And what we can see here is, well, as we modeled it exactly in Revit. There's a faceted column with 4 fins welded on. This is an editable mesh. What I'm going to do, because this is an instanced object, is use an Edit Poly modifier, and that way I'll get better results on the smoothing. I'll drop down on the modifier list and press E and go to Edit Poly. The Edit Poly then converts this to an editable poly, which in some ways has an easier structure to deal with than the editable mesh. Now get some smoothing groups on to make these round pipe columns look round. I'll right-click and choose Polygon, clicking and dragging across the vertical polygons of the pipe, but not the bottom. Note that I'm working in a crossing selection, and you can see this by the window crossing toggle up at the top. In window mode, we have to go completely around an object, whereas in crossing mode, our marquee has to cross that object or element. Now with those polygons selected, I'll scroll down, and in the polygon smoothing groups, click 1. These are our smoothing groups. Putting polygons in a smoothing group whose vertices are welded makes them appear to look round. When we deselect, we can see that we've got what looks like a nice round pipe. What I'll also do here is to select these and hold Alt and run my marquee across again to deselect, leaving me just the bottom polygon selected. This is an extra poly I'm not going to need, as it's facing exactly down to the floor. We can see it's there, both by the tiny bit of red highlighting the selection and the transform. I'll press Delete, and now it's exactly gone. I'll press F3 to go to wireframe, orbit around, and do the same at the top. Again, selecting the top of the column, holding Alt to deselect the column vertical faces, and then delete that top poly, looking to optimize anywhere I can. I'll get out of Edit Poly, and the really cool thing is, as we can see when I hit F3 again, that this change, because these are instanced objects, was made to all of them, that all of my cruciform columns now have nice round tops. It's working well. Now I'm going to take a quick look at the chairs. What I'll do is to go isolate them. Select them over here on the left side in my Scene Explorer, and look at just one of those Barcelona chairs. Here's our Knoll Studio Barcelona chairs, and I'll select one, and then isolate that selection, right-clicking and choosing Isolate Selection. There's our chair, and we can see it needs a little bit of help. I like the way it's detailed, but the smoothing is a little awkward. Again, I'm going to use an Edit Poly on it. Just putting that on adjusts the smoothing a bit. What we'll do in here is take a look by polygon and adjust how this behaves. If you'd like, you can press F4, which gives you wireframe on shaded. What I need to do is to really smooth out each individual square, making sure that they're all properly behaving. One way to do this is to start to pick pieces and auto-smooth them. I'll press 5 for element. When we open up the editable poly, there's our element. It shows us what we're dealing in. As I start to pick elements, I can see where their smoothing groups are. What it says right now is that this one element has polygons that are in some but not all of 1, 2, and 3 smoothing groups. If we pick 1, pressing 4 to go to polygon, we can see that this particular triangle is in group 1, and this one is in group 1 and 2, and that's why our smoothing's a little awkward. We're getting these dark artifacts. What I'll do is start to pick by element, clear it, and stick them in one group. When we deselect the whole thing, we get a better read. Because this is in one smoothing group, we see a nicely smooth tuft here with much fewer of those artifacts. These are caused by awkward polygon smoothing. So what I'll do very quickly is run through this object and make sure it's smoothed over nicely. Again, I'll select it and work by element. To do this a little bit more en masse, and knowing that these elements are unique by themselves here in this mesh, what I'll do is pick all of them and smooth them. We can see here that the back of the chair is a little different, so I'm going to work just on the seat itself. With all of these selected, I'll scroll down to my smoothing groups, and instead of assigning them uniquely, what I'll do is clear all and auto smooth at, let's say, 30 degrees. I'll press F2 or just deselect the object. This looks much better. Now what we're seeing is that this smoothing, because it's set to 30 degrees, is not catching the sides of those leather pieces. Instead, and I'll press 6 or 5 to go to element, pick one, pull it up, we can see that the straight sides of this tuft are staying straight. The top, this rounded section, is smoothing over, and the bottom is not smoothing at all. I'll undo to push that back in, and then work over the back in the same manner. It's important to get the smoothing groups right so that round objects look round, and things like this, with its delicate tufted leather, looks correct. And this helps us also avoid smoothing artifacts like that dark triangle there. I'll take a look at the back and see what's going on. It looks like just that bottom got welded together. I've selected all the back pieces, and we can see a couple of them are missing. I'll scroll down to the smoothing groups, and again, clear all and auto smooth by 30, and then go in and see why these polygons are hanging out missing. It looks like they didn't get welded. I'll press delete, and it looks like maybe they were extra in here. That one was not an extra. So what I need to do is go through here carefully and see what happened in that import. Again, not an extra. I'll weld these together then, picking these polygons, converting the selection to vertices by pressing Ctrl while clicking on the vertex button, and then welding the selected vertices. I'll scroll down and weld selected. Notice that weld threshold is really high right now, so I'll put this down to 0.05 and see how it works. Still too high. And there it is at 0.02, working nicely. What we're seeing here is from 673 to 641, welding correctly, and that should smooth nicely. I'll weld them, and then try that smoothing one more time. Clear all, and auto smooth. Then I'll deselect the object, press F4 to turn off the wireframe, and there's that tufted back. It's working well. I'll repeat this smoothing checking anywhere else, maybe taking a look at the welting on here, or the cords, and also the buttons. These look okay for the time being, as do the legs, so I'm pretty confident this chair will behave nicely. It's a good idea to really look over your objects for smoothing groups that may have gone slightly awry as part of the import process. Here's the neat thing. I'll right-click and end the isolation, go into my camera, or into the view and into the building and see those chairs, and all of them have that same modification. Because these are instanced objects, adjustments we make to the smoothing on one propagate through, so they're all going to look correct. I'm in my camera view, and I'll dolly this camera forward, clicking on the Dolly Camera button to dolly in. I'll hold Alt and pan, orbit around if needed, and take a look at my chairs. And what we can see here is they're behaving very well. They look nice and soft and pillowy as they should, without any odd triangles happening. The last piece to look at then is this Apollo wall. Again, I'll pick one piece, hit P for perspective, Z to zoom extents, and work over the smoothing. For these, I'll pick a polygon ring. We're working in a mesh, and that's going to give us some very odd selection and smoothing. So again, I'm going to put an editable poly, or rather edit poly, on top. Now I'll work by polygon, pick one, hold shift, and pick adjacent. It doesn't look like it wants to select. I'll try an auto smooth on this. Again, picking the whole thing and scrolling down to the smoothing. I'll auto smooth here by 30, clearing all and auto smoothing. I'll deselect, press F4 to get out, and it looks like it needs a little bit of help. What we need to do, it looks like, is take some things out of the auto smoothing, as this sort of mashed all together. It is all one element, but what I'm going to do is make sure that cleanly this outside face doesn't get smoothed in. So for all these outside pieces, I'll select these polygons around those loops, or whatever we want to call them, and clear them off smoothing. This takes a little bit of time to do, but it's worth it, because we want those crisp edges all the way around. Again, I'll select them and take them out of those smoothing groups. And we start to see our shape emerge nicely. It's working well. I'll continue my way around, and then separate the smoothing groups from top and bottom here to really make this shape stand out. Optimizing your file is highly important for rendering. Whether you're working out to a rendering solution or a real-time application, we need to reduce the number of polys, especially unnecessary ones, wherever possible. I'll take a look at some common culprits for having extra polys, such as my can lights. Then I'll take a look at these Barcelona chairs. I'll pick one of my can light objects, or rather, here's a spot, and I'll scroll up in the Scene Explorer and pick the can itself. These, again, are instance editable meshes. So I can use my editable mesh or editable poly, or edit poly, to modify as needed. I'll isolate it by right-clicking and choosing Isolate Selection, and then P for perspective, or T for top, and Z to zoom extents. I'll hold Alt on the mouse wheel and orbit around. So you notice I switch around in views a lot to see what I need. So we've definitely got some, well, very weird things going on. It's lit on the bottom, kind of faceted and funny looking on the sides, and definitely kind of awkward. I'll add on an edit poly. And the smoothing artifacts go away. Then I'll take a look at unnecessary polygons. This is buried in the ceiling, so this top polygon is not necessary. I'll go by polygon and delete. Additionally, this top ring is not necessary. And now we're down to the base can. It looks like we have another top end here that we can delete, and finally another top ring. This is getting better. We do have a reflector of some kind on it, and this is an option in here. How do you want to treat this? Should this can be an open can or have a diffuser on it? I'll pick this element and move it down temporarily to see what's going on, and it looks like this is a spare reflector object. Again, this is your choice. Does this stay on or disappear? It depends where you want the light and the quality of the can light in it. I'm going to leave it on and put a glass material on it, but what I will also do is really shape the nature of this can a bit. I'm going to pick this element that's the inside here and scale it out. It looks like it's just this one piece. And so what I'll do in a top view, hitting Z to zoom extents, is press R for scale and scale just on the XY plane to make this piece a little bit bigger and the can light a little slimmer. This looks good. Whoops, hitting Z to zoom extents again. Now I've eliminated some unneeded geometry and slimmed this mesh down. It looks like that scale didn't quite work right because there's an extra piece in here that didn't scale with it, so I'll show a slightly different approach. I'll undo, and now back in a top view, Z to zoom extents, I'll scale in a slightly different way. I'll work by vertices, pressing 1 for vertices, and switch my selection over to a circle. I'll click and drag out that circle selection to pick all those verts and then scale them out all together, slimming down that can in case I just want to show the baffles exposed with no glass diffuser. I hit F for front, P for perspective, and Z to zoom extents, and there's my can light. Now what we're also seeing is that this object has some kind of either incandescent or similar material on it, looking very bright here. So eventually we want to adjust that, or take off this diffuser entirely. But we've eliminated polys on this object. If you want to see how many polys an object has, press 7 to show statistics, or click on the plus in the viewport label and configure the viewports. What we can see here when we go to statistics is we've got a polygon count or a triangle count, and we can do total, selection, or total plus selection. I'll work by selection and click OK. This object has 9 polys or 208 verts, and what that means is that some of the polys, as befitting the nature of the editable poly, have multiple sides. If we click back on the editable mesh and press Hold Yes on this warning, we'll see we have actually 376 polys and 203 verts. Again, that's the difference between the poly and the editable mesh. Notice I also did a hold, so it temporarily saved where I was as I dropped back down under the Edit Poly, as I had done things that wouldn't change correctly through. Back on the Edit Poly then, we can see I've got my polys and verts going on here, and I've reduced that poly count considerably. Another way to judge this then is to go into the configuration, and here also look at triangle count versus just polygon, as an editable poly may have multiple triangles in each poly. Now what we'll see is I have 252 tries, which is actually what we use in rendering and what we'll export out to a real-time engine. When I drop back down to the editable mesh, again clicking Hold Yes, we can see I have 376. So I reduced down by 120 plus tries, which is a good amount of geometry to reduce. Now, if you're asking why go through this, remember that this is one of 5 in this rendering, and conceivably in a scene you may have dozens, and so taking off, let's say, 20 times 120 polys is a significant savings. I'll right-click and exit the isolation, and now I'm back here looking at my ceiling. And again, there's that diffuser we can take off if we need. Make sure to run through your scene and optimize other places then. We want to look for anything that's, well, excessively modeled and isn't really going to show nicely from a camera view. I'll hit C for camera and look at my can lights and also at these chairs. I'll pick one of my Barcelona chairs, isolate it, press P for perspective and Z to zoom extents, and then check out its geometry. This chair has 33,000 polys in it, a huge amount. Pressing F4 to show wireframe on selected then shows us where a lot of the geometry is. It's really in the cushions and this welting. At some point we just need these. We need it to look round, although we are seeing a huge amount of geometry right there. This is where we may end up wanting to do a little bit of remodeling to eliminate some of those tries. We can also look down here at these straps that wrap around. There's a lot of geometry going on, and this is an opportunity to do some reduction. I'll work by edge, and we can start deleting some edges. What we can also do here is make edges invisible if we need, but I'll start by just deleting and see how it looks. I'll scroll down to Edit Edges, and here's Remove. I'll use the Remove key and start taking out edges. I'll remove diagonals first so I get easier smoothing. Again, this is the advantage of the poly. Just simplifying down this structure a bit. And now I can look at taking out some of these facets. What I'll do is to start to take out every other one. Double-clicking on that edge loop, 1 up, 2 across, and 3 down. And now doing a clean remove, holding Control and clicking on Remove to remove the vertices. If we hit Remove and then we press 1 for vertices, we see a vertex floating free in the middle of that edge. What I'll do, again, back to edges here, by hitting 2 is Clean Remove. Hold Control and click Remove, and now we see that the vertex is gone as well. This may feel a little bit cumbersome, but it's worth it to start reducing down some polys, as we have thousands in here. I'll work through the rest of this piece, and then if needed, take my new one and clone it to the others and replace those elements, reducing down the number of polys considerably. We can also look at the welting. Again, this can be maybe a 12-sided or even 10-sided cylinder along here with a couple of edge loops modeled in and reduce down this poly load considerably. It's also worth a look at things like the buttons. We may end up wanting to replace these with hemispheres that have been scaled down. There's a lot of geometry that came in, and we need to be especially cognizant of it so that this renders nicely and smoothly. What we can see here is that that one piece that I've reduced the geometry on really renders the same as all the others, and I'm in a very close view. Most of the time we're going to see an object something like this, or if we get closer, we'll be more on top of it. Even in a VR application, we're going to be looking down at it. We really have to get down and look, and it'll still smooth out nicely. So it's worth taking out some geometry to speed up your render time, and then remembering that because it's an instance, those changes will propagate through everything else. I'll end my isolation and look for anything else in here I can go through and optimize. Sometimes in a model, it's necessary to increase the resolution of the model versus just decreasing or optimizing. Typically, we'll focus on optimization. For example, taking those Barcelona chairs and reducing the polys that are in a lot of the small details because we're never going to get close enough to see any fewer polys in that object. Sometimes, though, we do need some extra polys, and I'll take a look at this Apollo wall and the cruciform columns as examples. I'll isolate one piece of this wall. We can see here that this is 261 polys, not really that bad, and 346 tries. However, it really should be a little bit smoother, and this is where we could use a few extra edge loops. I'll take a look at the original and some reference just to make sure I'm on the right track. I'm back here on the Modular Arts site, and there's our Apollo, and we can see here that each of these rounded rectangles, or whatever we want to call them, is really nice and round on the sides. The only real faceting or hard lines occurs where the flat front and the round join, and then right here at the corners where it's got definitely a nice edge to it. This, though, should be nice and round along that long piece, so mine needs a little bit of work. I'll press F4 to turn on my edges, and I can see here that I've got a little bit of an awkward view going. I've got lots of triangles, and this is an opportunity in the structure of this edit poly to do some streamlining. What I'm going to do is start removing some edges to make a cleaner structure. I'll start to pick any of these diagonals and take them out to get clean quads. Again, scrolling down under Edit Edges and picking Remove. For this case, I don't want to do a clean remove because I want the vertices still there. I'm also going to take out some of these long, thin edges here. Again, removing them, and then I'll use my Cut tool to go across. Right-clicking and choosing Cut, and I'll cut from vertex when the Cut tool goes small, across to an edge, around, and back to the matching vertex, right-clicking to stop cutting. Now, if you notice, that edge is, well, kind of wonky. It's a little bit zigzaggy at the moment, so I'll snap it into place. I'll press 1 for vertices, W for move, and pick one of those vertices. Pressing S for snap, and what I'll do is hold Shift and right-click and make sure my snaps are set to use vertices and not grid points. Then I'll click and drag on the Z-axis. Now, as you notice, I may have free movement here, and so I need one more snap configuration. Holding Shift and right-clicking, I'll use the Axis Constraints and Snaps. And now, on the Z-axis in 3D, I can snap right to the adjacent vertex, as you can see by the green snap line, and get those even. I'll repeat and clean up. What I'm doing here is getting a better edge loop structure going. It's worth working this over so we get better smoothing all over, and we can more easily insert in additional edge loops to smooth out our shapes. I'll work my way through here and remove a few more lines and then show how I'd add in some extra loops. What I'd like to do is put in an extra edge loop to really smooth out across this section. It's looking a little bit flat. I'll scroll down under Edit Edges, and what I'm going to do is connect around. I'll press 2 for edges, and pick one of those edges where I want to add an extra loop. Then, I'll ring this selection. I'll press Alt-R to ring, And in here, under Edit Edges, Connect. If you'd like, you can use this dialog next to Connect to slide that around. What this lets me do then is pinch that together if needed, if there's multiples, or slide it top and bottom. I'll check OK, and now I've got an extra edge loop in here. I'll do the same on the other part. Again, picking one, Alt-R to ring, and connect. Here instead on the right-click menu, the quad. Now that I've got these in, I'll make sure I do the same on the other side. Ringing, connecting, ringing, and connecting. Now we can see here I've got some squirrely issues to sort out, as I just made a T there, where this edge comes to an edge instead of being contiguous, so that I can sort that out as needed. What I'm after there, though, is that in a front view, or actually a left view it looks like, I can now scale out vertices symmetrically to add a little more curve to this mesh. I'll start out by looking at the inside ones, changing my selection marquee back to a rectangle and picking pairs here on either side of the center, some manual symmetry. I'll press R for scale, and now I'll scale those out slightly for a little bit more curve. Then I'll do the same with the middles, so we perceive a nice smooth curve across here. If you'd like, you can do the same with the next row out. I'll pull these out slightly, and then deal with the centers. What we can see here is that now I've got a generally smoother shape, that it's getting much closer to the original, where we're not seeing the facets through the middle here that the original had. It's worth a little bit of editing here to get this looking right, as it's such a visually prominent piece. We know also from the reference that the original is smooth and this model needed some help. Adding in some extra edge lines, although a little bit manual, is a really great way to add in extra geometry versus simply smoothing everything, because that can add a ton of extra geometry if we use a turbo smooth or a subdivision. And in this case, get me just that extra curve to make sure this looks, well, correct per the original. I'll end the isolation, go back to my camera, and check it out, and it looks great. I've got nice curved edges on the sides. This is the kind of model where quite possibly we'll be fairly close. I'll dolly my camera in and look at the clipping plane on that camera to make sure I'm seeing things correctly. I'm in that camera, and I'm going to select the camera, and in here I've got my field of view and clipping plane. It looks like that near clip is set at 196, almost halfway out, but I'll bring it back to 1. It does look like we're outside of the glass, so I do need to move forward. I'll dolly again and bring myself in fairly close. It's very reasonable that in a view we'll see this wall from something like this, a very close view, or if we're in VR we may even get up to about here. We need to make sure then that objects that should be round are round and nice and smooth looking. And it definitely looks like I'm on the right track with this mesh. We can continue to smooth if we need and optimize in other places, but it's very important to check these things out from your camera view as accurately as possible, and this looks good. I'll get on to other meshes and see what else there is in here that may need a little extra geometry. Creating good terrain is a thorny business between Revit and 3ds Max. Often Revit terrain can be a little blocky or not come in correctly at all. We need to make sure we have good terrain, and in this particular building I need some gently sloping areas of terrain that I can plant. I'll take a look at some reference imagery on the original to see what the terrain is around this building. Quite often, I'll have maybe proxy terrain or at least loose guidelines in Revit, and then really, for a rendering, put it together in 3ds Max. We can see outside of the building that I've got these low retaining walls here, and these go around two sides and sort of end. Maybe there's a driveway or a parking lot going in. And I need some kind of slope from the wall or just below it to under the slab. I'm back here at some reference on my Santa Fe Savings and Loan. We can see it's essentially on a flat site. When we take a look at this first image, we can see that we've got a little bit of a slope and well-planted areas, and the terrain needs to go just under that slab and just below that wall. When we look at the side view of it, we see again that terrain needs to be gently sloping, and we want to put a little variation in. In this image, we can see we actually have a few more things going on. There's a low curb here, retaining some gravel that goes under the building, and then it's been planted with grass. Here's another image of it. And again, we can see that it's got grass around and that gravel in there. So I need to add a few more things in. We can definitely tell there's a little bit of a slope here. And so it's worth at least putting in a bit of terrain. Here's one more image of it, and we can see that low wall, and again where those plants and grass tuck under. So we've got different options going on. Do we want gravel and grass, or more dirt underneath with some plants? And I'm going to take that first approach. I'm back here in 3ds Max, and I've hit T for top view and Z to zoom. I'll hit G to turn off my grid and start to put in some terrain. There's a couple of ways we can do this. We can either start to make planes and sculpt them, or make one big object and sort of sculpt it into place, or start to do a flat mesh and use things like displacement maps and otherwise. What I'll do is create a series of planes and snap them together, as it's pretty easy, and then use some paint deformation to give them a little bit of wave. I'll hit Create and choose Plane. We can see that we've got this wall underneath, even with the columns. In this case, I'll use my snap, pressing S for snap, and snapping this first plane just inside those vertices. At the moment, I don't have anything to land on here, so I will need to manually move and snap this into place. Here's a quick way around this, though. I'm going to snap onto the wall and look at that height, a length of 235.625. Then I'll snap onto the other wall, and there's a length of 234.625, and I'll snap it on. Then, on the modifier panel, I'll put in that length, 234.625. My plane snaps out, and I'll move and snap it into position to fit. The question then is, how many pieces do we need across here? How many segments in our terrain? It's basically flat, but I'd like a little bit of variation. So I'm going to increase this up to 8 by 8. When we hit 7, we can see that we're into a grand 128 polys, which is perfectly fine. I'll add in a couple more terrain pieces. Again, holding Control and right-clicking and choosing Plane, and snapping this in. I'll snap inside the wall and onto the vertex of the wall underneath. Now I realize that I've got a mismatch in polys here, and so what I'll do is to change this ever so slightly. If this had 5 segments across, I could make them match up. So I'll change the width segments down to 5, and bring up the length segments to easily 20. So I've got some good variation across it, or the possibility for it. I'll add in one more piece across here, and then start to knit these together. Again, snapping on the retaining wall, and onto the plane. And for this one, I'll take the width segments up to 20, hit Shift-Tab and take the length segments down to 3. Now I've got a pretty good match. I'm going to convert these to editable polys and merge them all together. I'll orbit around and temporarily isolate these pieces. Selecting them by holding Control after I pick one, I'll right-click and choose Hide Unselected. Now I can start to get these terrain objects together, or these planes. There's a couple of different ways to get them to match up. What I'll do is look at the Z and just set all of their Z's here on the absolute mode transform type in to 0. They snapped in because I had the 3D snap on basically wherever they wanted. So I'll zero them out and then move them all back down together. Now I'll pick the first one, right-click and convert it to a poly, right-click and choose Attach, and attach them in. Then, in a top view, I'll press 1 to go to Vertex and start to snap their verts together for welding. Now that these are in, and it's one object, I can simply pick all the vertices, Control-A to select all, and right-click and choose Weld. And I'll use the dialog next to Weld so I can see how many are going to get welded. It looks like we'll weld together 10, which is correct. Now that these are all welded, I'll perform one final check, selecting by element. It's one element because the vertices are welded, and now I'm ready to do some sculpting. This is a great way to quickly augment or create some new terrain and sculpt it in with better tools than we may have in Revit. Alternately, you may not be able to get quite the results you're after with some contour lines, and so for something like this, as long as we know a general area and slope, we can do it fairly rapidly in 3ds Max. Now I'll unhide all by right-clicking, orbit around, press F3 to go back into Shaded, and pull my terrain down. I'm going to start this terrain out by moving it on the Z-axis, pressing spacebar for selection lock, and snapping down to the top of the wall. Then I'll pull it down a little bit further. It looks like a Z of maybe -12 will work nicely. Now I've got my starter terrain just under the edge of that wall, and it tucks under the floor there. Now what I'll do is start to brush this into shape. In the editable poly, if we scroll down, we've got paint deformation. I'll use this on terrain, as it's a great way for something like this to add a little bit of natural variety. I'll work by the original normals, right-click and choose Polygon, and then use Push-Pull. We can see in here my brush size is fairly small, so I'll bring that brush size up to maybe 60 and try a strength at 1. It's good, but a little bit too much. I'll take that push-pull value down to 4 and brush it in. Holding Control pushes in a little bit, and that's what I want to do. I'll spin around or make sure I can see the inside of that wall and start to push this down quite a bit. Alternately, if you're finding it's rising up too much, you can always push it down further and then brush it up. And I'm going to take that coarse. I'll take my overall terrain and push it down to a -16, and then start to brush it up higher. Here's my push-pull at 2, and just going to brush in a little variation. All this is doing is affording me the opportunity to have ever so slightly different terrain. A little up, a little down, a little bit here and there that's just, well, slightly different from everything else. Remember, we're not trying to create giant mountains here. We're simply looking for, in a camera view, a little bit of variety. I'll dolly back in my camera and take a look at my, well, scorching lime green terrain at the moment. I'll orbit this camera around, and it looks pretty good. Even in this view, we can tell there's some slight bumps in here, just enough that it's not exactly flat. Now, if you need, you can use this technique to make much greater hills, really adding in some variation. But for this, I just want it to be a planting bed, and so it's going to be pretty flat within a range, not exactly flat, which looks odd. I'll orbit around, use the roll tool to reset my camera, orbit around by holding Shift, dolly back, and check it out. If you find you lose your camera like I just did, I have no idea where I am. I'll hit T for top and go check it out. And it looks like my camera landed over there. I'll move it back over, hit C for camera, pan up, and check it out. One of the things I'll do for an easy check here is just to pick this object and not even bother with the material, but put a color on that's, well, dark. I'll take a look at it, and also in the view here, under lighting and shadows, turn on ambient occlusion. I'll make sure in materials that I'm using realistic materials with maps, and under lighting, either illuminating with scene lights or turning on the scene light control. I don't have a sun in at the moment, so it's going to look fairly dark. It looks pretty decent, with a little occlusion and a little bit of variation. We can definitely see our terrain has just a little wave to it, enough that it'll light as not perfectly flat. The building is looking good. I'd like at this point to add some more detail to a couple of things. I find that sometimes the fidelity of a model in Revit is good for Revit, but lacks some of the detail we expect here in 3ds Max. And especially if we're going to do a rendering, where we expect to see the lighting glancing off certain angles, rounds or chamfers, that we need a little touch-up here. I'll look first at this floor slab, as this is a key element of this building. I'll select it, right-click, and choose Hide Unselected. This floor slab was nicely modeled. It goes around the outside of the building itself, and is definitely clean and separate from the interior floor. However, it definitely needs a little bit of work. It's exactly flat. It was made with the 12-inch generic and, well, reads as a flat slab of something, not necessarily concrete. What I'll do then is to bevel all these outsides, or chamfer them. I'll select it and right-click and choose Convert to an Editable Poly. I personally like the poly structure better than the mesh, which is an older technology. Mesh is more universal in transfer, but the editable poly allows us greater flexibility in tools, selection, and smoothing. As this is a one-off object, that is, there's only one of them, I'm okay with converting it versus using an edit poly modifier like I did on the instanced objects. Now what I'll do is to chamfer all these outside edges. I'll hit 2 for edge and start to select all the outside edges here. I'm going to give them a bit of a chamfer so it looks like a cast concrete piece. I'll hold Control and work my way around to select them. With all those outside edges selected, I'll right-click and choose Chamfer. I'll use the dialog next to it, and we can see here that 1 is far too big. I'll use an edge chamfer amount of 0.1, and it looks much better. We've got a lot of options in here. Are we chamfering by triangle or quad? How many segments do we have? Are we opening the chamfer? Are we smoothing it or not? And so on. I'll uncheck Smooth because I want this to be exactly faceted, as if it was made with 45-degree corner strips in the concrete form. Then I'll click the checkbox to OK the chamfer. It looks good. We can see in here, as we orbit around, a really good, chamfer on it. It looks like we have some polys slightly facing the wrong way. We can try flipping the normal, but that's actually not it. It's an odd shading artifact. I'll flip it and flip it back. It's there, it's just not displaying smooth right, but it should render okay. All the others look good, and now we've got this definitely reading as a chamfered concrete slab. It's also 12 inches thick, and so this is one I might fix here. One of the ways I'll measure quickly is by using a plane. Holding Control and right-clicking and choosing Plane, or a rectangle works too. I'll snap a plane on, and we can see in here that this is a length of 12, a very thick slab. What I'll do is to take this object and pick all of its bottom vertices and move them up. I'll press W to move and F12 to pull up the Move Transform Type in. In here, I'll move them up on the screen Y, the offset screen, by 6. And now I've got a much more realistic concrete slab. Here in my camera view, it looks good, and I'll unhide everything else. We will need to go under and tuck those walls up that are underneath, but for now, it looks great. It's definitely much more like the original, where we've got that chamfered concrete slab over the dirt, really making the building float above its surroundings. On the roof, I'll use a slightly different technique. We've got this roof, and again, it's a one-off piece, one big roof as an editable mesh. And what I'm going to do is add a little bit of detail into that fascia. I'll take a look at the original and see what I can glean from the original photos. I'm here on a photo of the newly revamped building, the Palm Springs Art Museum Art and Architecture Pavilion. I'll zoom in and take a look, and what we can see here is that I've got a really nice fascia detail to deal with. There's this metal fascia on the outside and that smooth ceiling underneath, and so what I'll do is add a little bit of detail around that existing roof. Again, we probably could have done this in Revit, although I was putting in a roof and using it for design. What I'll do is use this roof as a template for a quick sweep. I'll hide everything else and go into a top view. Then I'll make up my profile detail. I'll hold Control and right-click and make a rectangle. I'm going to put in a detail with a fascia with some roundness to it and a gutter, and then sweep that around that roof. Here's a length of 12 and a width of 1.5. Additionally, here's a corner radius, 0.25, just a little bit of roundness. Then I'll zoom in and right-click, convert this to an editable spline, and start to take out pieces I don't need. I'll go by segment and pull out these top pieces. Now I'm going to add in that integral gutter. By vertex then, I'll take this top vertex, switch my transform over to relative, and pull it down by -4. Then I'll right-click and choose Create Line, or add another rectangle in. I'll create a line, holding Shift to constrain it to horizontal, and come up for the gutter. Now, being this is a gutter piece, I want to make sure that it's got two sides to it. Again, holding Shift, and I'll come back down and complete. I've got these vertices welded, and I will go in and start to separate these segments, as they got a little funny in the snap. I'll turn off my snap and get this gutter in place, again getting this profile looking right. What I'm doing here is making sure that I've got actually a double-sided piece, so I won't get any inadvertent shadow bleeds. If you'd like, and if you're never going to go up this high, you can also build the bottom of the gutter and leave the top actually totally enclosed. It'd be non-functional, but would save us a couple polys. In this case, though, I'm okay with it as it is. I'll make sure that these are all snapped on. And lastly, take all these vertices and right-click and make them corners. Then I'll set this one, right-clicking, as the first. That means that when it goes on a path, it'll run through that vertex. Now I'll take this roof and add in that profile. I'll hold Control and right-click and create a rectangle, snapping it nicely onto my roof. Then, onto this, I'll put on a bevel profile modifier. For that profile, I'll choose Classic and pick the profile, picking the profile I just made. Alternately, you could do this with Sweep. It really is up to you how you'd like to work. Now I've got that roof profile, and I'll take this object and align it to the bottom of that roof object. I'll hit the spacebar for selection lock, W for move, and pull it down on the Y-axis. When we switch back over to wireframe, we can see it's pretty good, although I'd like to optimize this a little bit. What I'll do in a top view then is to zoom in on that profile and select it, and in the interpolation take the steps down to 2, which gives me 3 segments over that curve, plenty for looking round. Now I've got that roof ready for, well, a little bit of editing. It's up to you how you'd like to handle this. What I'm going to do on mine, because my original roof actually overlaps slightly, is I'm going to take this original roof and take off the polys on the side, preserving the top and bottom, and attach to it the rest of this piece I just made. I'll go by polygon, picking the top, holding Control and picking the bottom, and then inverting the selection, choosing Edit and select Invert or Control-I. I'll delete the polys around the outside, and then right-click and attach the shape I just made. It's pretty good, although I'd like to do one other change. This element here that I just made is just slightly in the wrong place. I'll right-click to get out of attaching and just pull it down slightly. I'll press F3 to go to wireframe, F2 to turn off shading selected faces, and I'll pull this piece down just a bit. I want to keep the roof at this edge, so I either need to pull it down slightly and/or alter the bottom polygon a bit. As things do snap to that level, I'm going to pull this down a bit and then take the bottom polygon and move its vertices in. What we can do in here if we need is actually to pick by element and hide. Then start to grab vertices that are still showing and pull them in by -1.5. I'll do the same on the other side. Then I'll hit L for left view and take care of the others. Again, 1.5 and -1.5. I'll go back to Element and unhide all, and there's my mesh. This looks great. You can convert it to a poly if you'd like, or you could leave it alone. What I'm looking at in this, and we can really see when we get around to the corner, is that now I've got a subtle detail, where I've got my plaster ceiling in the right place, and I've got a new fascia and gutter detail on it, really adding a neat little rounded edge and extra shadow line around the gutter. From the top, it's light tight, and so will shadow very nicely on the interior. I'll check it out in my camera view, unhiding everything. I'll hit F4 to turn off wireframe on shaded and orbit that camera back around to the front. If you find this is slow, one of the things you can also do is hit P for perspective, orbit your way back around, and now zoom extents. What I'll often do is to use my perspective view to get a view right, and then hit Control-C to make a camera from it. I'll name this camera Entry Cam. And we can see I've got some really good detail emerging. My chamfered slab and roof with a gutter on it. Again, you probably could do this in Revit, but sometimes that gets outside of what's in a family. And so this kind of detail may be better added or easier added in 3ds Max. It also depends on what you're doing with your model. Are you separating the BIM model from the pretty model or the surface model we're going to run around in either a rendering or in VR? Assigning materials and where to assign them is an artistic choice. We're talking about the actual look of an object, not the material as in steel or stone or something else that Revit believes it to be made of, but in this case, what are these polygons covered on their surface with? I'm going to look at my materials here in 3ds Max. I'll often assign things here in 3ds Max, having left them generic in Revit. Not that I can't assign materials in Revit, but sometimes it's easier, especially more iteratively, to design here and then transfer back if need be. What I'll do first is see what do I need to assign, pressing M to pull up my Slate Material Editor. I'll roll up the Autodesk Material Library and look at the scene materials. In here, what we can see is I've got a couple of generics and defaults, and some other concrete and CMUs running around. The first thing I'll look at is what's got the generic Autodesk generic material assigned. By mousing over, we can see that I've got a whole bunch of objects that have this generic gray. What I'll also do is drag this into the view as an instance, and then, under Utilities, choose Select Objects by Material. In the Select Objects dialog, I'll click Select, and then take a look in the scene. I find it useful really to see it visually in a highlight, because often by name it's tough to tell. Additionally, if there's things that have a multi-material on them, where one material has multiple sub-materials assigned by polygon to an object, seeing it visually is a great way to catch everything. I'll hit P for perspective and orbit around. What we can see here is that all of my custom families, my cruciform columns and Apollo wall and these front doors, all need a material. The Barcelona chairs also need a material on them. They should be black leather and chrome, but it looks like they got missed in assigning. I'll go back to my material editor and get a paint color ready. I'll delete this instance, and under Materials, I'll use the Autodesk Material Library. It's up to you what materials you'd like to use, and that really depends on the application and the rendering you're going to do. If you're going to use the Arnold renderer, for example, start with Arnold materials. If you're going to use something else, maybe a hardware renderer or Mental Ray, you can use the Autodesk Material Library. If you're going to take this out to a real-time application, you may want to work with standard materials and then use the real-time application materials to really make things look right. I'll start out with the Autodesk Material Library, as I'm really concerned about the workflow here, not necessarily the rendering. In the Autodesk Material Library under Paint then, I'll pull in the paint. I need to get a color on this, so I'll double-click on it and get a name and a color in. I'm going to use some Sherwin-Williams paint colors for this particular design. I've browsed through their color collection and settled on the SW6342 Spicy Hue, a rich, warm orange or clay color. It shows me here the RGB values and a hex value, 153, 75, and 53. Back here in 3ds Max, I'll name this SW6342 Spicy Hue. What I'll also do is put in a designation for the sheen. I'm going to put these in an eggshell, slightly shinier than flat, so it's got a little bit of better wear on the outside. I'll often use a 2-letter designation in my naming as a way of keeping track of what's going on. Now to get the color in. When we click on the color here, we can see that there's a slight problem. These RGB values are in a 0 to 1 scale versus the 0 to 255 scale given on the Sherwin-Williams site. But here's an easy way to convert. The standard scanline material colors work in a 0 to 255 scale for RGBs. So I'll put in 153, 75, and 53. Now that I've got these colors in, I can drag them back and forth or eyedropper them as needed. I'll right-click on this color and choose Copy, and then here in my Autodesk Material, right-click and paste. And now there's the right color. What we see also here is that there's an image in this Autodesk bitmap. It's just a paint, and I'm going to take it out for the moment. What this does is give us a little bit of a surface nubble, a little bit of a texture in it. There's the color on it, and it looks like this is being used as a bump as well. For the moment, I'll take it out. Now I've got my spicy hue going on, and I can add a little bit of gloss if needed. We can use a slider or use a map for the glossiness. What I'll do is to bring up this slider to about, let's say 10. This is a 0 to 100 scale, so just about a 10% gloss will work nicely. And I'll check highlights. We'll get a little bit of a specular highlight on it, and I'll also put in a touch of reflectivity. In this case, I'll bring down that reflection. I'll pull it down to maybe 15% for each for both direct and, well, maybe around 20 or so for oblique. So we get a little bit of a shine to it depending on how we look at it. Now I'll get this assigned. In my scene, I'll hit H for the Select from Scene dialog. And in here in the filter at the top, I'll type CR, and there's my cruciform columns. I'll select them all and click OK. Then I'll take this material and click on the Assign Material to Selection button. Now these columns all have that material. I can work my way through and assign the rest of the materials in here. Alternately, we can pick existing ones and add something different to them, and I'll show how that looks with my glass. Right now in the scene we've got glass, and it's a good Autodesk glazing. It's on all of my doors and system panels. I'll drag in it as an instance, double-click to open it up, and we can see in here it's, well, clear glass. Right now it shows as 2 sheets of glass, and it's a clear glass. It's up to you how you'd like this to look. We could tint it or go custom, or bring up or down the reflectance. What I'll do is to bring up the reflectance a little bit and take the sheets of glass down to 1. It's 1 sheet in here. It's working nicely, and if you'd like to see how it behaves, you can also turn on the background in the view. Right-clicking and choosing Show Background in Preview. This really gives us a good indication of what's going on with that material. As we take down that reflection, we see through it, and the reflection becomes more of a Fresnel reflection on the outside. I'll pull that all the way, well, reasonably back up to about that 20 or so it was, and it looks good. This is assigned to all those glass objects. If you'd like, you can always choose Utilities and select Objects by Material to see where it's assigned. It's assigned to all these pieces cleanly, and so that works very nicely. We need to make sure, as always, that we've got the right material assigned in here, and using the Selected Material by Name or Select Objects by Material is a great way to go. Lastly, I'll take a look at those chairs. In the Scene Explorer, I'll select my Barcelona chairs. Then, I'll isolate them or hide the unselected objects. I'll zoom in and get my materials going. These are one object, so we need a multi-material for them. What I'll do is to select the different pieces and assign a material. I'll get the material ready first. Here in the Material Editor, I'll make a multi-material. Right now, we don't see one on there, and so what I'll do is go up to my Standard Materials, and under General, pull in Multi-Sub-Object. In this multi-sub-object, I'll set the number down to 2, and then start to pipe in those materials. We can use our generic Autodesks or our Autodesk Material Library. Under Metal, I'll pull in Steel, and here's honed, knurled, galvanized, and so on. I'm going to use a polished brush on these as Material 1, and then I'll bring in a black leather on the upholstery. What I'll use for the leather is actually a black rubber, and I'll adjust the sheen. I'll double-click on that material and call this black leather. For the color, I'll bring in nearly black. And then I'll bring up the glossiness, check highlights, bring up the reflection on the oblique just a bit, and just the tiniest touch on the direct. I'll double-click on that sample to check it out, and it looks good. If you'd like, you can also play with the performance tuning, but that's beyond the scope of this course. Now that I've got this material made, I'll name it, and we'll call it Barcelona chair. Now I'll assign it to my chairs, picking all 3 of them and assigning the material to that selection. It sort of works, although it looks like they all went chrome. Here's how I'll handle this then. In this editable poly, I'll go select by smoothing groups, or by element. I'll start picking by element the legs, and in here I'll change their material ID. Under Polygon Material IDs, I'll set the ID of these to 1. Then I'll start to pick the other elements and set them to 2. Another way to do this is to select all of them and set them to 2, and then start to pick the easier pieces to select, like the frame, and setting them to 1. I'll orbit around and check it out. It looks pretty good. It looks like there's a couple more pieces to catch, and I'm in good shape. We can work our way around and catch the rest of these pieces, assigning those materials. It looks like there's one bar in back here that needs it as well. Here's how I'll catch tough stuff like this. I'll zoom into a place I can see it and use my crossing selection to start to grab these different pieces. This is a unique one because we've got a lot of pieces that are, well, intermingled. I'll use that crossing selection, going across those pieces and selecting them. It'll take a little work, but remember these are instanced objects, and so working by polygon should work fairly nicely. I'll make sure I don't have any of the sides selected and change the IDs on these to 1. Now we're starting to see that chair emerge. It's looking good. It looks like we need to play with some of the straps in here to make sure that those actually do stay in the black leather, but the chair is coming to life. We can work our way around, changing the polygon IDs as needed. I'll unhide everything, go back in my camera view, and see what else I need to assign materials to. It looks like there's more to work over. The doors, the curtain wall system, and so on. But we can go through and assign them just as easy as we did those other pieces. 3ds Max has fantastic tools for UVW mapping. UVs, or UVW coordinates, are the coordinates by which an object gets an image wrapped around it. This is different from the XYZ coordinates defining the object's vertices and hence the object. In this case, our UVs, as they're more commonly known, define how a flat image is wrapped around a 3D object. We've got terrific tools, and I'm going to go through and do a little bit of remapping on some of my block walls. I'll pick one of them and hit P for perspective and orbit around. It looks decent, although there's some things I'd like to change. We've got the right number of blocks tall, but right here on the corner I'd like this texture to wrap around better. Also on the top, I either need a cap texture or a separate cap material, or maybe even separate cap geometry. What I'm going to do is to get the mapping flowing around this corner nicely first, and then see how I want to make it work on the rest of the wall. Onto this object I'll assign, under U, a UVW map modifier. Unwrapping is when we actually unfold an object onto a texture, and I don't quite need that at the moment. Because I'm going to use a tileable map, or one that repeats, I can use the UVW map modifier quickly. What I'll do is to set the length and width of this to 4 by 4, or 4 feet square. Then I'll align that gizmo on the Y, and that way it projects flat across the wall. I'll hit 1 to go into the gizmo, turn off my snap by pressing S, and scroll it down a bit so I can see it. Now if we rotate this gizmo 45 degrees, hitting A for angle snap and rotating, it works nicely, but there's a problem. Aside from the map being absolutely enormous, which we'll deal with in just a minute, it is smearing it and stretching it across here. First, I'll get the map looking right and then come back to this odd rotation, making this block flow around that corner. I'll look at the material and probably do a quick remake on those blocks. I'll pan over to a new spot in my view and then pull in those concrete masonry units, which is on my block. I'll instance it, or simply double-click on it to open it up. What we can see here is that these concrete masonry units are masonry, using a map for the color and a map for the relief pattern of the bump. What I'd like to do is take a look at this map. I'll click on it, and there's that map. And we can see in here it's got a big scale, 3.9 by 3.85. What I'd like to do is set these back to 1 and 1. And then look at the repeat. I want it to repeat horizontally and vertically. And the blurring is pretty good as is. That blurring determines how it fuzzes out in distance. Then I'll take a look at the image. I'll select it and click View. And what we can see here is that we've got 3 blocks across and 6 tall. At 16 inches nominally per block, that gives us a 48-inch or 4-foot square map. Now here's the trick in the mapping. I'll make sure I don't zoom off screen here. And what we can see is by rotating that mapping, I've stretched the block, but it is flowing around the corner. So here is that trick. For mapping like this, what we'll do is multiply the width of this mapping by half of the square root of 2. The square root of 2 is 1.41. Half of that comes out to 70.75, or 70%. I've pulled up my calculator, and just to show this math then, here's the square root of 2 divided by 2, 70.71 loosely, times 4. And that gives us 2.82. I'll round it up and call that width 2.83. And it's scaled down. Here's what's going on. Because this is rotated 45 degrees, it's like the hypotenuse of a 45-degree triangle. And the difference there is from 1 to 1.41. So we need to compensate for that scale using that 70.75% to bring it back to the right width to length ratio as it's rotated. Now, ignoring the top for the moment, it looks really good. What we can see then is we've got this mapping gizmo 45ing and spanning around this corner. I'll hit W to move and move this gizmo around. And what I can do with this is slide that texture so that cleanly I get blocks wrapping the corner. Now this is a 12-inch wall, and so we either need more blocks, bigger blocks, or a cap on it. But at least I can get that block to wrap around. Now what I'll do then is to right-click and choose Top Level, and right-click on this modifier and copy it, then select my other wall, right-click, and Paste Instanced. Now what I've got, excluding the top, is that this texture spans cleanly around the wall as if this wall was built contiguously, which it would be. It looks like it was built with maybe 6-inch thick blocks instead of the full 8s. Then we can pay attention to the top. We've got some options here. We could hit them with a generic concrete material as a cap. We could make cap geometry, or we could change the texture on here and map it straight down. If we try to span this, it will decently work. It depends also where we're going to see this from. What I'll do is on this use another selection and another mapping. I'll drop down here under Poly Select, and by polygon I'll choose the top polygon. Then I'll paste on my mapping again. I'll change the width back to 4, rotate the gizmo back 45 degrees, and flip it 90 degrees over. Now, you can't see what I'm doing here because that face is shaded, so I'll press F2 to turn off the shading, and there's that mapping. And I'll move this gizmo as needed. What I'll do is slide these together so that the block joints start to align, and at least reasonably, on the corner, it looks like our blocks are in the right place. We can definitely see we need a little either mesh surgery or another material here, but we can do the same on the top face of the other one, and it'll look pretty good, as if somebody considered at least having top and corner blocks to use on this wall. When you're done, you can right-click and choose Top Level and deselect and check it out. I'll go into my entry camera and take a look. This wall looks pretty good, and I'll orbit around to see. It's working nicely. We can see that block repeating along the wall cleanly and over the top, and that same texture wraps and spans around that corner, so the block looks contiguous. There's a lot of instances where we can use this kind of mapping. Block walls, brick walls, anything with a repeating texture that needs to flow around a corner, where in Revit it may not quite handle it well, but with a little bit of mapping adjustment here in Max, we can really make things shine, or rather, look, well, like they're supposed to. Substances by Algorithmic are a terrific way to add procedural textures into your model. There's a wide variety available, both from the Algorithmic site, and you can author them using programs like Substance Designer and Substance Painter. Substance Designer gives you procedural materials, substance archives, that you can easily bring into materials here in your Revit model you brought into 3ds Max. I'll show how to integrate a couple in, and what we need to do regarding the mapping on certain objects. I'll start by adding some dirt texture to my, well, dirt plane here. I'll press M to pull up my materials, and I'm going to make a new material for that dirt. Under my Autodesk materials, I'll use the Autodesk generic. I'll double-click on it to make sure I'm seeing it, and I'm ready to start to add in my substances. For substances then, we need to add them in as a map. I'll look under Maps, and under General, there's Substances. I'll drag in a substance, and then double-click on it. What we need to do, once we've got the Substance Map node in, is to actually load our substance. I'll click on the Load Substance button. In the default 3ds Max directory, there's actually a Substance directory in the Maps. In the Program Files, under Maps, we've got Substances. And in the Substances, there are noises and textures. I'll go take a look in Textures. In here, we've got a lot of different substances available. Dry ground, crumpled paper, concrete tiles, and so on. I'll scroll down and see what's available for dirt. There's a dry ground that may be too dry looking. There's gravel, which could be pretty good, or grass. I'll try a gravel and see how it looks. I'll click Open, and double-click on the preview to see it. This will be a good-looking gravel. If you'd like, you can always right-click on that preview and choose Open Preview Window. This gives you a preview window you can float around and enlarge as you need. This will work nicely for my gravel on that dirt, and I'll plant in it, as if they had planted and then covered with a gravel ground cover. Now I'll start to connect these. I'll take the diffuse and put it over to the generic image. What it'll do is put a source map in as the output here. Then I'll take the normal and put it into the bump. Again, this will add a map output on. I'll double-click on that, or right-click and open up a preview and see how it looks. Typically what I'll do is keep my preview window auto-updating. Then I'll start to bring in things like specular. We'll take specular over to glossiness, and finally height over to bump amount. This will give us an extra little lift on it, making it look a little bit taller, more vibrant. If you'd like, you can also bring in displacement or bump, but I'm going to leave those alone for the moment. There's no transparency or reflectivity we need at the moment, as it's a fairly matte surface. I'll rename this material, calling it gravel. There's my gravel, and it looks pretty good. We can always adjust this if we need. I'll leave reflectivity off, but turn on highlights, so I get little winking specular highlights as I move around this. I'll leave the glossiness maybe at, let's say right around 25, not terribly glossy. Again, we'll leave reflectivity and transparency off and cutout off, and it's not a glowing rock, so no self-illumination. I will turn on the bump, and this will give me a little extra bump to it. We're making sure that this comes in as a normal here in the bump. And we can always push up the amount if need be. Personally, I like to have my bumps run a little bit higher, roughly in the 100 range. If you'd like, you can turn on ambient occlusion, as this will add the ambient occlusion in from other materials, which is kind of nice on the rock for a little bounce. Now I'll assign this. Clicking on the Assign Material to Selection button, and also making sure that the Showing the Shaded Material viewport is enabled, so I can actually see this rock. Now I'll take a look at it. going into a perspective by hitting P and orbiting around. It's a little funny looking because it needs mapping coordinates. Remember that most things coming in from Revit will have square mapping. Most things that you make here in 3ds Max will have default mapping, which you probably will mash by modeling. So we need to adjust them, as we've seen, to do some mapping on it to really get things to flow around. I'll put a UVW map modifier on, and in this I'll shrink down the size. The default size of this mapping, as we can see by the orange mapping gizmo, is to fit to the whole object, and so I get giant boulders in my texture. I'll take this down to something smaller and square. Here's 60 by 60, 5 feet square, and that seems to be a lot better. I've got my gravel going in here, and we can see the repeat, but I'm going to camouflage with plants at some point, so it's okay. I'll check it out from my camera, and it looks pretty good. It's definitely gravel. We can see some variety. There's a little bit of wave we can see here from brushing that plane into place, and I've got gravel on there ready for planting. Now I'll take a look at putting a substance on the inside. I'll take one of my floors here and hide everything else so I can see it clearly. This is the main floor, and I hit T for top, Z to zoom extents, and G to turn off the grid. Like with many objects, this can stand a little optimization. What I'll do is go by Polygon, pick the top, press F2 to show shaded selection as I had turned that off at some point, and then Control-I to invert that selection and delete. Now it's down to a simple planar object instead of a big thick floor. In truth, it should be a big thick floor, but we're never going to see it, so it's okay to optimize. I've opened up my material editor and panned over to a clear space in View 1. Now I'll make another material and bring in a substance. Again, under Materials Autodesk, I'll bring in a ceramic. I'll take the default maps it comes in with and move them over just a little bit. Need to give myself a little bit more room. I'll even open up my material editor here. And now I can start to put in the material, the substance, actually into this material. First, I'll delete the initial bitmaps it comes with and enlarge that sample. We've got a good shiny material, and I'm ready to start putting in the substance. For the color then, I'll use a map. Click on the button for map here and choose substance. In the substance then, I'll load a substance. And under textures in the default substance directory, I'll take concrete tiles. There's my concrete tiles, and I'm ready to add in the other substance components. Again, it's given us a substance and a source map. Double-clicking back on the material, we can adjust the type from porcelain to ceramic to mute out the highlights a bit. And here's the finish: polished, satin, matte, and I'll choose a satin. Nice muted concrete. And I'll add in a relief pattern and browse the substance into it. We'll take the normal from the substance into the relief alternately with the material selected. You can click on No Map under Image and pick Substance again, or browse your substance across. I'll bring the amount here up to 1, and we can really see the relief in it. Actually, it's a little bit too much at 2. There it is at 1, with a little variation across that surface. I'm not going to use round corners, as we're only going to see this as a flat object, and there's my finished bumps as well. In the finished bumps, we can either put in our bump or a height. I'll pull a height across, and it looks good. I like the way this looks, and I'll make sure that Finish Bumps is enabled. We can add a little bit of wave if we need, and change the type, custom, map, and so on. And now it really shows nicely. For this, I'll enable ambient occlusion in the material, using color from other materials, as I want to pick up that bounce. We're going to leave round corners off, and leave the reflection glossy samples for now at 32. We can always tune a material if we need. Now I'll apply this. Again, renaming it to concrete tiles. Here's how we can tell how big to map this. When we click on that map, go into the substance itself, we can see that we've got map tiling at 1 by 1. Real world scale is off, and we have a texture size just set to 1 by 1. Right now, it's going to default to a 1024 square until we adjust it. That's the nature of a substance, is they are procedural. If we go and look at one of the other maps, we can see in here that I've got 4 by 4 tiles. So I'll map it in some version of 4 square, maybe trying 8 square for 2-foot square tiles. I'll assign this, show the map in the view, and I'm ready to map this. We can see the default mapping from Revit is maybe a little bit small. As a gauge, I'll lay over a rectangle, holding Control to make a square. And we can see in here, when I make a rectangle that's roughly 4 feet on a side, we can see how many tiles we get. So we definitely need to map this properly. I'll select the object and add a UVW map modifier on. Now we've got absolutely enormous tiles, and I'll take the length and width down. Here's 8 by 8, giving me 2-foot square tiles, or we can work with a real-world size. I'll try that option, checking real-world map size, and then in the material, pressing M again, for each of these substances, checking Use Real-World Scale, and I'll put the size here at 8 by 8. And there's that mapping. It's really an option. Where would you like it to sit, and how big should it be? Is the material designated at a certain size by a manufacturer, let's say 2-foot square, or is it something else? I'll go into my entry camera, unhide everything else, and check it out. I need to pan this camera over and dolly in just a little bit. Looks like at some point I'll need to add new glass in here in these doors, as right now they're just an open frame. But the tile looks good. It'll work nice across this entry. The substances then provide a terrific way to get realistic materials in easily. And because they're procedural, they always start from a different place and are generated and much smaller than the equivalent images, the bitmaps we'd bring in. Take a look on the algorithmic site or take a look at Substance Designer for making your own if they're not available from a manufacturer, and make sure that they're mapped correctly so that you get the right size and right starting point for your material. The materials in a scene from Revit definitely need some fine-tuning. They're not bad, but they're just generic placeholders, and so we have some opportunity here to really add a little pizzazz, put a little shine into things, and make it look, well, exactly like we want. Unless you've fine-tuned your materials in Revit, the ones that come in then are fairly generic placeholders, as I've said. What I'll do is take a look at the curtain wall system and buff out that aluminum just a little bit. I'll press M to pull up my material editor and choose Edit and Clear View to clear out this view. We could make another view if we need, or just pan over. Either way is fine. We're not losing the materials. Now I'll use the eyedropper to pick material from an object, and we can see we've got the Autodesk aluminum on here. It's actually aluminum as an Autodesk metal, and it's set to a satin finish. Here's some different ways to fine-tune this quickly. Remember, what we do here shows up on all those objects that have this material. The first thing is to look at the metal. We've got aluminum, anodized aluminum, chrome, and so on, and I'm going to change to an anodized aluminum. Then, I'll turn on a relief pattern. Right now, we can see in here, and I get a quick message from the art renderer saying the gradient is not supported, which is okay. There are images piped in, but there's nothing going on. If we double-click on one of these to what's happening in the parameters, we can see the source is nothing. It's the same with the other one. They're there and ready to do something if we'd like. I'm not going to use any cutout, as this should be a solid surface, so I'll delete this one, close the error message, and now add some relief. What I'll do for the relief pattern is to drop down here under Neural and choose Custom Image. I've created an image we can use for the relief. I'll click on that image, and in the source, click on None. In the Images directory in Scene Assets for the Chapter 3 Exercise Files folder, you'll see a targa called Brushed. What this is some simple vertical grain and motion blur I did in Photoshop, and then downsized with an enlargement filter. That may sound weird, but here's what I was looking for and why I did it. I wanted generally vertical lines with a little bit of wave, softly blurred together so we didn't see too much dancing because of single pixels that stood out, and I wanted them to maintain some of their quality. And so rather than shrinking them down with a shrink filter, I use the enlargement, blur, and massage them together a little bit. They started out at 1024 square, and now it looks pretty good at 512, and it's a nice small image. I'll click Open, and this will be my relief pattern. It's a little tough to tell at the moment, but it'll work nicely. Now what I'll do on this is double-click on the material again, and then increase the amount on that relief. I'll put it up to 1, so it's got a little bit of relief to it. And then I'll add in the ambient occlusion and round corners. This is what I'll typically do, allowing the ambient occlusion to show within the material and use the color from the others to bounce onto this. I'll also turn on round corners and blend with other materials, so that even though it should be absolutely perfectly machined aluminum, it's really got a tiny little bit of roundness in the shading, so it's not perfect and too crisp. I'll lower this amount down to 0.1, and I'm going to leave the performance tuning alone. As you can see, we've got a map or a spinner available for the round corners, and being that this is not mapped consistently everywhere, I'll use the spinner. Now that that's on there, I need to map these objects. It didn't need a map before, but because I've used this image on it, we have to map it, but that can be taken care of easily. Here's how I'll handle it. I'll press H to pull up the Select from Scene dialog. And in here, as we scroll down, we can see all the quad corner objects, rectangular mullions, and V corners. So I'll start with the V's, taking all the V corner mullions, picking one, holding Shift and picking the last one, and clicking OK. And I'll just hide unselected. What we can see is I've got a few verticals and mostly horizontal. So I'll map the horizontals first. I've gone into a top view, and what I'll do is to select them by direction, picking all going this way, vertically, holding Control and adding more to that selection, and grabbing these here on the end. And now I'll map them, dropping down to the modifier list and choosing UVW Map. And I'll map this, again, as a square with a length of maybe 12 by 12. Actually nice and small. Then I'll rotate this 45 degrees, pressing E to rotate, and orbiting around so we can see, rotating the mapping gizmo at a 45. Now repeat this process for the other ones. In the top view, selecting all that are running horizontally, and mapping them. Now we can copy and paste the mapping if need be. Here's how that works. I'll right-click and copy it, and make sure I've got these selected. And then I'll paste. In this case, the mapping is instanced across these objects, but not instanced to the verticals, and then I can rotate it, pressing 1 to get into the map gizmo, and in the rotation, rotating 90 degrees. It's already rotated at a 45, and so this maps nicely. We'll take a look at this and go through and map the others. Now, at the moment, if we look under our materials, we can use realistic materials with maps. To make sure this is actually working right, I'll go in the material editor, and with that material selected, make sure it's showing correctly in the view. If you'd like, you can even show this shaded material, this map in the view, and see if we can see it. It's there, and it's working. We can go through and map the other pieces nicely, and this will get us a good striation across here, just a little bit of variation in that aluminum instead of a perfectly smooth surface. I'll repeat this with all the verticals, unhiding the quads and other pieces and mapping them at a 45 to push that mapping through, as all it's doing in the relief is adding a little bit of wave in that reflection and shine. I'll do this, show what it looks like when I'm done, and then look at the white that's on that Apollo wall. I've gone through and mapped all the mullions, and when it renders, they'll look great. Now take a look at this Apollo wall here. Again, I'm going to eyedropper that material. We need to replace our generic here. In this case, I'm going to make a new material and assign to all those pieces. I'm going to use the same bright white on the surrounding wall as well. I'll choose Materials, Autodesk, and Autodesk Wall Paint. Here's that default wall paint, and I'll name it for a Sherwin-Williams color, as I'm using on my other pieces. I'm here in my Sherwin-Williams colors, and I'm going to use a nice bright white. This is high reflective white, and it'll look great on that wall. In here, we've got RGBs we can put in. 247, 247, 241. So it's just about bright white. It's actually got a little bit of warmth to it. Back here in 3ds Max then, I'll name it. We'll call this one SW7577 High Reflective White. And I'm going to put this in an eggshell. Then I'll click on the color. This pulls up our color here, and we need to be pretty close to white. What I'll do is to bring these colors way up. Now, we can also go and get the equivalents if we need. I've put it in as 0.99, 0.99, and 0.98, just about bright white. I'll click OK, and then in the finish, I'll change this over to an eggshell, a nice bright white. There's our high reflective white, and we can also play with how this was applied. Is it a roller, a brush, or a spray? And for this, I'm going to do it with a spray. Again, I'll turn on ambient occlusion, and in the shader, use the round corners and blend, because this will give me a really nice rounding on those different pieces of the Apollo wall. Then I'll go and select it. I've got one selected, and I can see that it's named MA Apollo Wall. Again, I'll press H to hit or select by name in the scene, and type in the search filter, MA. There's those Apollo wall blocks, and I'll click OK. I'll also hold Control and select the surrounding wall, and zoom in on them so I can see. Then I'll assign this material, and make sure I catch that extra wall piece in there. And there's our bright white. I'll take a look in the entry cam again. It looks good. It's really got that bright whiteness to it. I've done a quick render here, and it's working nicely, just with the standard art renderer. Again, the lights in here are just the photometrics that came in from Revit. I haven't really touched them. We're just seeing the interior lights, almost like a night shot, so we've got dark in the foreground. I haven't adjusted the exposure, but really what I'm looking at is just the general shading of that wall in those down lights, and it's showing very nicely. Our efforts are worth it. What we're seeing here is that I've got the flat faces of this wall and the relief showing well. It smooths nicely and has a very soft appearance because of those round corners. It's behaving properly. Definitely have some variation across in the shine and the overall look. One more test in the material, and I encourage you always to test. I'm going to add on a photographic exposure, choosing a physical camera exposure control, and then in here we've got our exposure values. I'll render out a preview, and then start to play with that exposure value and temperature. I'll bring up the compensation exposure value just a bit and render one more time, just kind of brightening up the image in a quick test to make sure this material is really working. It's a little bright, and I definitely need to work on the speckles I'm getting here. And that's part of really fine-tuning the render. What I'm really after in this is just to make sure that it's looking nice on all those different contours. We can always go play with the speckling in here. That's not a big deal in the render quality, and I haven't chosen a renderer yet. I'm looking at the overall material, and it's reading very well. Make sure then that you fine-tune your materials. There's lots of opportunity to really bring out the life in the materials very quickly, without too much effort and without too much texture work. But just to get in a little bit of subtle variation across here will really help. Getting the lighting right is really crucial in a rendering. The lighting that comes in from Revit may be decent, but could use a little adjustment. There's also some things we can do to speed up our rendering and get rid of artifacts. I'll take a look at my lights, going into a top view, pressing F3 for wireframe and panning over till I can see them. This group of 4, and then 2 over here are my surface mount cans. Then these 5 are my recessed fixtures I added in. The first thing I'll do is to turn them on. You may ask, why did we get light earlier in a rendering? And the trick is that the glass on these can lights was self-illuminating. So we're actually lighting from the glass being a lit object or lit material rather than the lights themselves. What I'll do is to pick these lights then and turn them on. Note that any lights that come in as a part of a family from Revit are instanced, just like the rest of that family, so that turning on one or adjusting the properties on it adjusts all of those instances. What I'll do is to choose a template. I'll start out here looking at my bulbs. I'd like these to be nice and bright, so I'll run them as a 100-watt bulb to start. In this case, what happened is that it changed over to a uniform spherical, and I'd like to make these a spot. This is where we have some artistic license in rendering sometimes. We can either use a photometric working from a true bulb, or set them up as spotlights to get a more artistic wall wash. It's up to you in the mood you're going for. I'll turn on my others, my surface mount cans, again taking them and changing their template. For these, I'm going to run also a 100-watt bulb and see how it looks. Again, they change over to a uniform spherical, and I'll move them back to spot. I'll take a look at these spots and see what else I need to adjust. In a front view then, and making sure that these lights are on, we can see the spot. The yellow is the hot spot, and this is the area where the light is at 100% strength. It fades out to 0 here at the fall-off, this darker outside cone. You may also see this referred to as cone and penumbra or something similar. Really what it refers to is where does that light fall off over distance as the light comes out from the source. We can play with the target distance and, if we'd like, make these targeted. I'm going to leave them alone as I'm simply good with that visual representation for now. We can see here that they've got a color temperature Kelvin of 2800, and that's giving us a nice warm light. I'll see if it's too warm or if I need to adjust it. They're also at 139 candles. We can also play with different ways of viewing this light, lumens or at a certain distance and so forth. For now, I'll leave it alone and see how these look, but there's one more adjustment to make. These can lights, the recessed ones, are modeled and lit, well, exactly as the real ones are. The lights then are inside the fixture, and this can be possibly problematic. If we were to render, we'd get, well, no light from these, and here's why. This object, selecting it and right-clicking on it, is casting shadows. When we go into the object properties, we can see that cast shadows is checked. There's two ways to handle this. Make it not cast shadows, and then we're still dealing with the light ray tracing through the glass, or move the lights down just a bit. In reality, nobody's going to know the difference, so what I'll do is move them down. I'll pick these lights, and here's how to do this easily. I'll pick one so I can see the name. Press H or select from scene, and in here we can see that this light is a child of that recessed can. So I'll open these all up and pick the lights in there. As you can see, I've also filtered down my display. The default looks like this, where we can see all the objects in the scene, all the different types, lights, cameras, helpers, models, and so on. What I'll do is to uncheck lights and then hit invert display, and then just pick my lights much more easily. I'll pick them all, press W to move, and I'm going to pull these spots just down under the glass. I'll leave the glass right now as self-illuminating, but with the lights below, we'll get a better wall wash in the scene. Now I'll test this out, hitting C for camera and choosing my entry cam. I'll try a render and see what this looks like. We haven't played with the render quality, obviously, but the lighting is looking really nice. I do need to adjust the exposure, but what I really like in here is how I've got a warm light and I can really see the detail in that wall showing nicely. I'll pull back a touch and see how these look in other places. So far, this is working very well. I'm outside, and it's kind of a night shot. What I can see here, aside from the reflection in the glass of the inside, is that the lighting is working wonderfully. The lights look like they're on, at least the recessed cans. We may need a little help on the surface mounts, but for now, the light quality is really good. It is a little bit on the warm side, so we could adjust that temperature Kelvin or deal with it in post, but I really like the way that the softness of the light is spreading in that space. Remember that your lighting is an artistic choice. We can light with our photometrics or with spots and really bring that scene to life, and doing it with lots of little lights to really add some play in the space is worth it. We want to light this space to evoke a certain mood, to show off the architecture, and a little tweak here and there is worth it. And also, save time where you can. If your lights need to be just below the fixture so we're not dealing with shadow casting through all the fixture, go for it. Nobody's going to know the difference, and you'll get that wall wash with a lot less render time. In a design visualization, we often want to animate the lights coming on. This can be problematic sometimes to select those lights and turn them on, as the different banks may have different lights in them, different instances. And so rather than go in and select them all, what I'm going to do is add a manipulator on the screen that can control a bank of lights. I'll do this often because I have many lights that aren't always instances or easy to select. Here's how this works. We'll create a manipulator and then wire to it. First, I'll make the manipulator on the command panel, going under Create and Helpers, and under Helpers, Manipulators. In the manipulators then, I'll put a slider on the screen. I'll click to land it, and then go to the modifier panel and name it. For the label, I'll call this Lobby Dimmer. This is a dimmer that's going to control the recessed lights and the surface mount cans. This way I can dim the lobby or turn it all on at once without selecting different things. I'll start the value out at 100, full strength on the lights, leaving the minimum and maximum from 0 to 100 and putting the position at 0.85 and the Y at 0.05, so it's nice and tight on the top right of the screen. Sometimes what I'll do, depending on the building or whatever it is I'm working on, is to put in a row of these, kind of working as a light board easily, so that from any view I can see these and turn them on or play with the lighting. Again, this is just a helper so that we don't have to go and select the individual lights. We can snap if we need. I can put the snap value at 1 so we're working in percents, or just turn it off as we're going to simply slide them like we would a dimmer. Now that that's in, I'm going to wire it. To wire it then, I'll right-click and choose Wire Parameters, and wire the Object Slider Manipulator's value to something. That's what this drag line says. I'll wire it over to this light. If you can't click easily on the light, you can always press H for Select by Name and choose the object you want to wire to. And there's my recessed can incandescent. I'll pick, and in here I'll put the Object's Free Light multiplier. We'll go from the value to the multiplier. So in the parameter wiring dialog, we need to set up our control direction. We have the option in here. Is it a two-way? Is it a right to left or a left to right? In this case, because of the order I chose these in, I'm going to go left to right. The slider value controls the multiplier. If you need, you can also add in expressions here, math, like ×2 or something else. Once you've got that, you can hit connect. And what we can see in here is that I've got a Bezier float value controlling a float wire, so it's working nicely. Now we'll check out that light and see what it looks like. What is that wire doing? I'll pick the light and scroll down. This light has a value of 139 candles. We have a resulting intensity and a manipulator, which I'll turn on. And now what we can see is that this is 0.85% of that, or 1.2, very dim. That slider then shows at 0.85. What I'll do then is to click Select and Manipulate and drag that slider all the way up, and now we can see I'm at full value. I'm controlling all 5 of these lights just by selecting and manipulating. Now what I'm going to do is to wire in those surface mount cans as well. And this is really where the power of this comes in, being able to control multiple unique objects, or not instanced or not sharing the same properties. Here's that wiring again. I'll select the manipulator, and I'll right-click and wire from the slider's value to something else. What am I going to wire to? By name, pressing H to pull up the Pick Object dialog, and there's my surface mount can lights. And I'll click Pick, and again I'm going to wire to their multiplier. This again will be a one-way, from the value to the multiplier, and connect. We get the same reading, that from the manipulator, which is already a Bezier float, over to the multiplier as a float wire. It is controlled by it. And then I'll make sure I pick these lights and turn on their multiplier. So right now, because the manipulator is set to 100, I've got these at 100%. Here's where things get cool. I'll select and manipulate and pull this down to 47, and we can see my resulting candle power on these lights is 65.3. What we can also see is that on these lights, I've got that same multiplier coming in. So now I've got control from one manipulator to all the lobby lights. I'll dim it down and do a quick test render. What we can already see is with these lights dimmed down, well, the lobby is dimmer. We can definitely tell that these warm circles on the floor are not nearly as bright. I'll crank this up to 80% and render one more time. The lobby is definitely brighter, and so now I'm controlling both banks of lights with one manipulator. And again, here's the cool part. I'm in my camera view, and I can have anything else selected. I'll dolly the camera around, and that manipulator is persistent on the screen. So without having to go and select the objects, or maybe they're hidden or I can't see them or whatever it is, I've got control over the lighting bank in that scene, and we can animate one manipulator to turn on those lights in an animation. The goal of bringing this Revit model into 3ds Max is to fine-tune it for rendering. Now this is not a rendering course, and so we're not really looking at a particular rendering engine here. We're also not looking at this in a true real-time application. We're prepping for real-time, where we drop into a game engine and run around this scene or put on VR headsets. Instead, we're simply looking at the workflow from Revit to 3ds Max and what we need to do to fine-tune and polish these objects. So I'll use a test render in that context, not necessarily making the prettiest image, but testing some things in the rendering to make sure that it'll show up nicely in any given renderer, whether I'm using Arnold, V-Ray, Corona, or the art renderer here. What I'll do first is to pull my camera into the lobby and turn on some things in the rendering and the camera to really check, is this going to hold up nicely? I'll go into a top view, press F3 for wireframe, and zoom out to find that camera. I'll take my camera here, press W to move, and make sure that I'm moving the camera itself. Right now, it looks like we're using the selection center, so I'll fly this out and choose the pivots, and there's my camera. I'll pull this camera forward and just sit it inside that corner to look over at that wall. I'll press C for camera and take a look at the Z height of that camera. It's a little tall, so again, I'm going to go into a front view and pull it down. It looks like it's aiming down as well, that really it's high in the scene and the target is pretty low. I'll pull this camera down, and we can see here where it is in the scene. It's at a Z of about 79, still fairly tall. So again, I'll pull this down, and there it is at 75, just over 6 feet. Just a touch under, 510 will work nicely. Then I'll take this target, and again, pull it up roughly even with the camera. I'll press C for camera to go in, and check it out. I haven't really concerned myself with what lens I'm using in here necessarily, or a render size yet. What I will do is increase the render size and then test out a few things in rendering. I'll go in the render setup, and in the common tab, here's our render size. And under output size, I'm going to choose HD. Most likely this will be seen in some kind of HD display, whether it's on a TV or a widescreen or something similar in a game or anything in that range. This is a good way to test. I'll downsize this render to 1280 and then check out in the art renderer the parameters. I'll bring up the render quality to high. This will give me a pretty good render without being a complete killer in time. I'll also turn on the noise filtering and bring it up to 50%. Again, not absolutely stunning, but a lot better than it was. We still may see some speckling. It's pretty good overall. I do have anti-aliasing on with a filter diameter of 3 pixels. We can add some blurring if we need, but I do want some crispness to show, so I'm going to leave that alone. Then I'll hit render and see how this turns out. Now, I haven't adjusted exposure of the camera yet, but I want to be able to take a look at this with some constraints on in a minute once I see how it's behaving. As the render progresses, I'm getting some really good results. We've got good detail showing on the chairs and on the wall, and also the stepping, the additional segment of wall around that Apollo wall. What I do see is that the can lights are a little bit bright, rather the glass is, and the chairs are showing well. What I'm going to do next, now that I've affirmed this is basically going to work fairly nicely, is put on a little bit of depth of field and see how this behaves. One of the things we'll see, whether it's in a real-time application or in a render, is we're going to put on things like depth of field. And so what I want to do is test render with things like that on to make sure that my model actually will work when it's slightly blurred, and see if anything that's going to be in the foreground and focus needs more detail. I'm here in a top view in a wireframe, and there's my camera target. It's a little bit far out, and so I'm going to take this target and actually move it back to focus on that wall. Then, on the camera, selecting that physical camera, I'll scroll down and turn on depth of field. This will allow me to put on depth of field, and we can either use the target distance or a custom focal distance. What this relates to then is that aperture. The aperture size then, as it says, affects exposure and depth of field. We're going to get a shallower depth with a lower aperture. I'll take this down to try an f4 and see how it looks. And we can see where those planes are going to go, where that depth will sit. I'll go into my camera and try one more render. My render is progressing nicely. There's still some speckling, but I'm less worried about that. What I'm looking at is with the focus on this Apollo wall, I've got a little bit of blur in the background. Now typically, I'll do my blur in post when I'm rendering, but I like to use this one to test, are my objects going to work decently when blurred? Are they going to show up nicely, and is there anything else I need to do? I like the resolution I'm getting on the chairs, the wall, how the lighting is spreading, and how the floor, the subtle details, are showing up. In the back then, it looks like these fairly boxy aluminum mullions will show up very nicely. I do feel that the window frames in back definitely need some different material, as in that dim light, or in any light, they're showing as, well, fairly orange, and that's not quite the color I'm after. I also see that I need to retouch a bit that concrete block material or put a different one on. Maybe specify it as a classic modernist Roman brick, actually, with long, low horizontal lines, or do it in flagcrete or something similar. Whatever you'd like, this is a good way to test out then if this is really working. Are we seeing in here that things are holding up nicely in a render? And are we approximating how we'll see it in something like a real-time simulation, where we're going to mostly bake this lighting and then run around in the scene, seeing things real-time and looking into all kinds of different places with some post-effects on. In tandem with render settings are the exposure settings. Right now what I've done is simply put on that exposure so I'm not completely blowing out the scene. Actually, I've got a decent dim light going because there's no light fixtures in the rest of the building. I'm isolating the render down to this test case of this lobby. What I will do is typically play with the exposure settings to make sure that in a rendering, when I'm dealing in, let's say, sunlight or bright interiors, that things will hold up nicely. That even with a nice bright exposure, I won't get too much blowing out. What I'll do for this is to clone some of my surface mount lights so I get more light in the space, and then play with the exposure. I've got surface mount lights over here on the side, and what I'm going to do is to take them and hold Shift and clone them over, watching the distance I'm cloning. There's a 6-foot offset, and I'll instance them. And then I'll take this group of 4 and Shift clone it again back into the space. Now, we could do this in Revit, but I'm using this simply as a test case to see how this behaves. I'll clone these over and light up my space a little bit more. I'll go into my entry camera, and then click Select and Manipulate, and make sure that multiplier is all the way up, that my lights are fully on. Now I'll look at the exposure. I'll press 8 to go to the Environment and Effects dialog. We've got two things going on here. One is our ambient light may be tinting our render, so I'll click on that ambient and pull it down to 0. Then I'll look at the exposure control. I'll render a preview and see how this looks. It's working fairly nicely. What I am seeing is that its white balance is off. Right now it's set for daylight, and I'd actually like to switch that over to incandescent. Much better. It's still a warm light, but it's definitely not as orange as it was. What I'll also do is make sure that things like my white material are showing up well, that with a white material and bright light, I'm not losing any detail in this model, seeing if there's places I need to adjust or anything like that by playing with that exposure. Typically what I'll do is also adjust the image control, so I'll add a little bit more darkness to the shadows, pop the highlights slightly, and leave the midtones alone. We'll leave our exposure scale at a custom 1500, the default, because we're working in a true physical scale here. Then I'll bring down that exposure value just a bit to 5 and test it out. It looks good in the preview. We've definitely got some good light going on, where it's nice and bright in that scene. I'll make sure my lights are all on, selecting them and scrolling down and checking their multiplier. They're nice and bright, and I've got good light coming from them. Some of that orange in the scene then is coming from these being an incandescent, so we can also play with different lights if need be. It depends on what's specified in the scene. Really what I'm after is just to proof the exposure, to make sure that reasonably when I run a physical exposure of some kind on it, that things basically show up fairly nicely and adjust a little bit. Again, this is not a rendering course, so I'm not going to get deep in the nuance of fine-tuning a render for interior-exterior. I'm simply looking for anything that's an obvious goof in a model or needs more attention when I adjust that exposure. In a test render, even though it's still resolving, it's working pretty nicely. It's a little hot on the top of this wall, but that's because of the exposure value coming up. So that's one to watch out for. Just to note that it's probably better to play with more lights or add a little bit of daylight in or something similar than it is to really use the exposure to brighten the whole thing up. Now here's one other trick I'll use in the exposure to really watch for things looking correct or not. I'll stop this and go back into that exposure dialog. I'll scroll down and zero out the saturation. It's going to give me a black and white image, and here's where this is really fantastic. The rendering is progressing, even though it's still resolving. I use this black and white and look at the values in it to see if things are going to read nicely. Do I need to play with material or shine or anything? Now personally, and this is from my architecture training where we had a full semester on black and white photography, I love working in black and white. I think that the ability to really craft the sense of place and space without the muddiness of color and really let the design shine is a huge deal. Some of my favorite images I've made have been black and white renders of a color space. Now, what I am looking at in this is in running in black and white with that exposure, do I have anything in here that needs adjustment in normal or in shine or any other property besides the color of the material? I want to make sure that without color confusing things, that the way the light is looking on the objects is correct. It definitely looks like my surface mount cans need some attention. They should look more metallic. My window frames are holding up pretty nicely and they're in the background. I've got a good shine going on these Barcelona chair legs, so I like how that chrome came out. And even though they're just dark black and not in great light, I can really see a little bit of detail in the chair, so it's holding up nicely. This white wall is working well, and even in a black and white, I've got good relief and good play in that floor, maybe impersonating a terrazzo or something similar. So again, switching to black and white in that exposure provides a great way to just test and look at both the value in a render and composition, and to see if anything in your materials or lights needs attention without the confusion on the eye of the color of things happening. Thanks very much for watching my course, 3ds Max Revit Integration, and I hope you had as much fun bringing that model from Revit into 3ds Max and fine-tuning it as I did. If you'd like to go further, here's some courses I'd like to recommend on LinkedIn Learning. If you're interested in the Arnold renderer, check out Aaron F. Ross's course, 3ds Max Rendering with Arnold. It's a great primer on the Arnold renderer, and really can bring your renderings out to a stunning level. Check out my course, Substance Designer for Architectural Visualization, if you're interested in procedural materials and creating substances of your own, or to match a certain manufacturer's product. This is a great starter course. Lastly, there's a series of texture courses, creating metal textures, creating metal 3D textures, creating wood 3D textures, shingles, and slate. These are all short courses in Adobe Photoshop that will teach you how to make materials quickly for use in your renderings to really customize the look of your Revit model in 3ds Max. Again, thanks very much for watching my course, and make sure you get those Revit models into 3ds Max tuned up and looking great.